Okay, so let's start right in. What is 3D printing? Now, simply put, 3D printing is an additive process. We are adding material to create an object. So if we look at the illustration on the right, we can see that layers are stacked one upon each other to become an object. It's pretty cool. You've got nothing on your print bed, and then, hours and hours later and hours later, you have an object by material being added on layers stacked on top of each other. This is one method. There's other methods, but they all involve adding things to other things to create this shape. And this is a lot different than a lot of other manufacturing processes. If you think of, I use the example of say, an artist creating something out of marble. You start with a block of marble and you chip pieces away to get your object. With 3D printing being an additive process, you're adding material to get the object. And it does this by taking your 3D drawing that you either downloaded or you created in something like Fusion 360, and it converts that to math, which we all love math, right? And it uses that math, sends it to the 3D printer, and it creates a solid shape using one thin layer at a time. And that is where the magic happens, right? When we come down in the morning or we go down there after hours and we see something is starting to be created. If we look to the right, we see this boot, and I don't know why someone printed a boot, but someone printed a boot. Maybe they needed a replacement for Monopoly or something. I don't know. But you can see the little layers in this print, and that is what we're talking about with the additive process. We're adding one layer stacked on top of another. Now, there are other types of printing technologies, and let's take a look at them. Okay, so the two models that we will look at predominantly are the two most popular models. Now, the most popular printing process is fused deposition modeling, or FDM, and that's like the one we just saw with the boot. It is a roll of filament being extruded through a hot end through a nozzle, building an object one layer at a time. So that's the one that when you're thinking of 3D printing most of the time, that's what you're thinking of, and that's what you're seeing on different sites like GearBest and Amazon and whatnot. Now, the other very popular one is stereolithography, or SLA. And you might have seen this. This one looks even more magical. It is when you have this sort of pool of photopolymer, sort of plastic that's affected by light or laser. And what'll happen is you have this pool, the print bed lowers into it, and a laser starts shooting into this photopolymer, hardening it where it hits. And as the printhead raises from the pool of liquid, there's your shape, there's your object. So those are the two most popular, FDM being the most popular, and we'll talk about why. Now, again, there's many other different processes that are out there. Some are more for, and a lot of these are for different sort of applications. Some are more for scientific, some are more for industrial. For example, DPL, a lot of these are also based off of or similar to SLA in that they use a laser or some type of arc light. So like digital light processing, it's very much like SLA, except instead of a laser, it uses like a hot heat from an arc light to actually harden a part. And sintering is interesting. SLS, that doesn't use a liquid plastic or a roll of plastic. That actually uses powder, hardened powder. It hardens powders of either metallic powders or nylons or ceramics. And, you can get some really highly precision pieces on this because the dust, it's powder, it's dust. And it's so small that the laser, when it fuses that, you can get some really, really high precision pieces. Again, these aren't two things you're probably going to have in your home, more industrial, rapid prototyping, that type of thing. And as you can see, there's even more. We have a selective laser melting, and that's where we're using different types of powders and different types of heat sources, and that's what all of these are, different materials and different heat sources. For example, laminated object manufacturing, or LOM, That is using thin sheets of plastic that are actually rolled under heat and pressure to create solid objects. So again, not something you're going to have at your house. These are all processes that are additive and that will create things over time. But the mostly ones that we're going to see in our home are going to be these two. We're talking again about the SLA, stereolithography, and FDM, fused deposition modeling. And if we look at these two images, we can see that on the right, the FDM, that's what we're kind of used to seeing, or if you're just getting into 3D printing, you might not be. And we're going to go over all the pieces, parts of this type of printer. Now, we're building this little owl up one layer at a time. If we look to the left under SLA, we can see that bottom orange sort of tray. That's got the polymer. It's deeper than it looks, and it's filled with the polymer. And the upper thing, the upper sort of black area there, that is the print bed, and that's lowered into the plastic. The laser hits it, and it raises up, and where the laser has hit, we get a solid object. So it's pretty amazing to see it happen. Again, we're going to look at the differences in cost and quality of print right now. So if we look at FDM, what are the pros? Now, widespread adoption. These are the printers that most people have. It makes it a little easier to get help, a little easier to get advice in different groups. And I'm going to actually have links to some of those different groups and help areas in the last section below. Now, the mechanism is simple to use. It, relatively simple. It takes a little practice. It takes a little time. They're affordable. You can get a 3D printer for $150. The consumables are cheap. Rolls of filament, you can get them as low as, I've seen them as low as $12 up to, for the more exotic filament, more expensive. We'll talk about filament in another lecture. Now, some of the cons of FDM, it does require some thorough calibration because you got to make sure your print bed is very flat. The print quality is not as high as some of the other technologies. Since we're laying down this layer of plastic, we're stacking it on top of each other, you can sometimes see layer lines. You can sometimes get a little shifting. So it isn't as super sharp, but it's still, again, for what it does, it's pretty amazing. And it needs maintenance and care. I'm not sure if this is considered a con. Any printer needs maintenance and care. This one is no different than any printer, SLA or whatever. Now, SLA printers, again, what are the pros? You can get some very, very detailed prints because of the fact that the laser is so fine and we're heating this polymer, and where it hits it, boom, it's just hardened, and it's pretty amazing. Very, very smooth prints. And of course, you're able to use different types of resins, glow-in-the-dark resins, hardened resins, clear, opaque. You can buy some different cool resins, just like you can buy different types of filament. And of course, due to the laser and due to the liquid plastic, the liquid photopolymer, you're going to get a more precise and strong print because it's not built of layers, it's built of a solid shape. Now, what are the cons? Of course, when we're talking about something that is higher, it's got high detail and high print quality and increased precision, that means one thing: it's going to be more expensive. We're also going to need a higher level of technical precision with these types of printers because sometimes it can be tricky to figure out where your supports go and getting the plastic set up. They can be a little trickier than a standard FDM printer. Again, they need maintenance and care, but to me, that's any printer. And I think one of the bigger ones too is the expense of printing materials. The printer itself, we're talking about anywhere between $500 up to thousands of dollars, and $500 would be a very, very low end one, very, very small bed. You're usually talking anywhere between $1,500 to $4,000 for a printer like this, and then on top of that, the actual resin is a lot more expensive than, say, a roll of filament. And that's one of the reasons in this course we're going to be focusing on and learning about FDM, printing fused deposition modeling. This is the one that you're more than likely going to have in your home. This is the one you're going to start with. It is amazing. It is fun. And learning some of the things we're going to be talking about will help you make great prints right off the bat. And if you have any problems, it'll help you figure out what they are and how to fix them. Let's take a look at a brief history of 3D printing. And I say brief because it hasn't been that long. Now, I know some of you are saying the 80s, that was a long time ago. Well, not to me. It doesn't seem like it was a long time ago. So here's one of the first 3D printers. I found this image out there in the Googleverse, and it is huge, right? And again, that little thing over there with a tiny, tiny screen, that is an actual computer. So you can see how large that 3D printer is, and I'm sure the print area on it is just that little sort of reddish cylinder in the middle there. So tiny, tiny. Now, if we look at the 80s, there's some definite huge things that start happening, where in the first patent is actually released or applied for by Dr. Kodama for rapid prototyping. He's looking at how to make prototypes in manufacturing that don't require, to make a die and to mill the steel and do this. He wanted to come up with something that can make a little doodad really quick to see if it would actually work before you spent the money to make this huge investment in tool and die stuff for metalwork. Then later on in 86, Charles Hull starts taking up stereolithography, so SLA printing, and he founds 3D systems. So we've got these different types of technologies happening. Then we jump to 1988, and Scott Crump, he comes up and patents FDM. So here we go. This is the guy. I'm sure there were many others involved in the office and in the laboratory that helped him come up with this. But he patents the FDM process that we use now. We also can jump to 84, where stereolithography is also taken up by the French for using things. Again, people are working on all these things at the same time. One of the biggest myths about technology is that if, let's say Edison didn't discover the light bulb or electricity, nobody would have. Somebody would have, because there's always other people working on these things all over the world. And then again, then we have Carl Deckard in 88. He brought a patent for SLS. That's the sintering that's using the powder. So we have all these different technologies starting to emerge. And obviously, they're all sort of feeding on one another and saying, well, what? If you can do it with this, you could probably do it with that, and coming up with these different technologies. Now, let's take a look at the 90s. And here is one of the first patents. This is a drawing for a patent for the, this is from Strathus in 92 for FDM printing. So this is one of the patents. This is a patent. I love how 36, I'm wondering what that actually said. I'm assuming monitor, or maybe it's a keyboard. 38 is keyboard. And if we look at figure 1, in the next lecture, we're going to be taking a look at the parts of a 3D printer. And a lot of that is what we're going to be looking at, but really condensed down into one tiny piece. So it's pretty fascinating when you take a look at something like this, an actual patent from 92 for an FDM printer. Now, when we hit the 2000s, we can see that things start definitely kicking into a high gear. A 3D printed working kidney is created. We also see that the first prosthetic leg is made in 2008. This is a big one. FDM patents are now in the public domain, and that's why we can have all of these different printers out there, because anybody can make an FDM machine. So again, patents are great, but when patents also are allowed to be used by others, and when they lapse, we can start creating some really, really cool things. Now, 2010s, I guess that's what you'd call it, right? 2010s. One of the big ones here was in President Obama's 2013 speech, State of the Union speech. He mentioned 3D printing. which was amazing because here's this technology that is getting bigger and bigger, and it's being talked about in the State of the Union speech. I mean, it wasn't a huge part of it, but it really made the industry say, oh, wait a second, we're actually getting somewhere, we're doing something. We also have all these different things happening where, they're starting to print with carbon fibers, and we're looking at doing things like 2012, the first prosthetic jaws printed and implanted. So we're using these things for rapid prototyping at this point, but not so much using it to, but we're also using it not for just machinery, but we're using it to create pieces of ourselves. So like the computer, 3D printing has just jumped leaps and bounds from the 80s till now, where, for example, I have 3 3D printers just printing away downstairs right now, and they're making some pretty cool stuff. We can 3D print body parts. We can 3D print prosthetic legs. I have seen 3D printers that are working on 3D printing flesh for skin, for burn grafts. In the last section, I'm going to have some links to some really interesting articles, and some of those are in there about the history and sort of what's happening now. So it's really a really fascinating process that I can't wait to talk more about. So let's take a look at what are the pieces, parts that make up a 3D printer. And for this, of course, we're going to be looking at the FDM printer that most likely we will have in our home. Now, the pieces and parts of a 3D printer are right here. These are pretty much all of them. There might be some little things like screws or zip ties or whatnot that aren't listed here, but these are the biggies. And we're going to take a look at each one of those things to learn what they do and what part of the printer they are. Okay, so here is a standard FDM printer, and this just happens to be the CR10. It's the printer I have. It's just a fantastic printer. We'll be talking more about this later on, different types of printer to choose, but this is a standard 3D printer. And first thing we're going to take a look at is the print bed. And this really matters. It's where the print happens. It's where the print is built. And there can be a couple different kinds. There can be a heated bed, and you might guess that those are beds that get hot. They are heated. And the heat definitely helps the print adhere to the bed because you've got hot plastic. It hits a hot surface and it bonds to it and it sticks. If it got to a cold surface, a lot of times it will slide around and it won't stick. So a heated bed is a good thing to have. I would definitely, if I was going to get my first 3D printer, get one with a heated bed. And most of them come with heated beds. And of course, as you might guess, a non-heated bed, not so much. There's no heat. There's no heat to it. They don't heat up. And it can really, create warping because the plastic hits it and then cools. Things might not stick to it as well. So a heated bed is really important. Now, the other thing with your print bed that you want to look at is size. Now, this size is roughly 300 by 300 by 320 or something like that. So the bigger the print bed, the bigger prints you're going to be able to make. So as you can see, this print bed's pretty large and very high. So I could make a print that is pretty much that wide and as high as this printer is. Now, you're going to use a lot of filament, but you can do that. So you've got to start thinking, what am I going to be printing? What do I want to print? Are these big things for cosplay or for, your own prototyping? Are you going to be making things for modeling? What size printer do you need? And that'll, of course, affect both the cost and, pretty much just the cost, because obviously the bigger the printer, the more expensive it is. Now, a big part of your 3D printer is your extruder drive feed. And this is this little guy over here that's on the 3D printer, and it feeds the filament through the printer, or through that gear there, that brass gear, and it feeds it through and into the tube and then out the nozzle. So again, all printers are going to come with this. This is a metal upgrade. I'm going to have links to certain resources. One of them is different types of upgrades you can do to your printers. But this one right here, this is the entire unit. This is the drive feed. And we're going to look at the pieces of this drive feed as we go. Now, one of the things that you're going to find in a drive feed is a stepper motor. And also in other areas of your 3D printer, but this is the motor that will drive these gears so that the printer will feed the plastic through. So these are very, very important. Now, two other things that we looked at that are on our extruder feed driver. If you look, there's that little geared thing and the other little silver thing next to it with the screw. That's these things, the hobbed gear. Now the hobbed gear, you can see how it's got those little teeth on it. And those bite into the filament and push it through to the hot end, the place that melts it. So this is a huge piece. The stepper motor turns this and feeds it through. Now, the thing next to it was the idler gear, and that sort of just, you use it to, you can adjust the tension. If you see this screw here with the spring, you can adjust that so it's either pushing that idler gear harder against that hobbed gear or the plastic against it, so it's getting a good bite onto it, and it just sort of guides and holds and creates a little bit of tension to keep the filament in line so it doesn't move all over the place and gets fed through. So these two things are very important. Keeping your printer in good maintenance to make sure that these things are tight is a great thing to do. We're going to be looking at that in the bottom of the sort of the troubleshooting section on things that can go wrong. When things go wrong, a lot of times this is one of the pain points, something going on in your extruder drive feed. Of course, another part, I guess technically this isn't a part of the printer, but you definitely need it, the filament. And it's made from different polystyrene or nylon, different types of plastics. And this is your filament, and it's obviously used to create the actual print. Okay, the next thing we're going to do is look at the extruder, and this is where the magic happens. This is what feeds the filament. We've already looked at that, the feeder, and of course the second part of that is the hot end, and that's that chrome piece in the image over there. And that's made up of its own pieces, parts that do what it needs to do. But it's in that chrome piece that the filament is fed, heated, melted, and then extruded, say out that little brass end, that little orangey brass colored nozzle out the bottom. Now, before we take a look at some more detail on the hot end, which is, again, where it all happens, let's take a look at, there's two different types of drives, two different types of extruders and engines that we can use in 3D printing. And the first one and the most popular one is the Bowden extruder, and that uses a Bowden tube, which is just a Teflon tube, and you can see it in the printer to the left. The filament would be over on the left of that printer. It would travel through that white tube, down the white tube into the hot end, which is behind that fan, and out the nozzle. And then off to the right, that is an actual picture of a Bowden tube. So the filament and the hot end are at a distance from each other, and it travels through that tube. Now, a direct gear is much different. You can see that there is the actual Bowden tube sort of connection up top, but what you would actually feed through there is the filament. And as you can see, there's the hob gear and the idler gear, and there's the feeder, and it feeds directly into the hot end. So here there is no difference. The filament goes into that little white knob at the top of the device, goes through the hob gear and right into the extruder. So there is no distance to travel through the Bowden tube. Now, this can be of a benefit sometimes, because sometimes a Bowden tube can get clogged or crimped. But again, most of the printers you're going to see, they use the Bowden method. Now, what are the pros and cons of a Bowden extruder? Now, a Bowden extruder, the pros, it weighs less, which cuts down on vibration. Now, as you can guess, if something's trying to do something precisely and lay down layers of stacked plastic, you don't want a lot of vibration because vibration will cause defects in the print. Some of the cons: filament, it needs to travel through the tube and it can get stuck along the way. And it's hard to print flexible filaments. We'll talk about those in a little bit, but you might have guessed by the name, these are filaments that are very rubbery and will create a rubbery material. And in this way, it can't feed through that tube. And you can get more oozing and retraction because of the space between the gear and the hot end. So what that means is when you retract the plastic so you don't have stringing or blobs of plastic, since it has to retract all the way through that tube, there's such a distance, the retraction can be a little tricky and you can get, again, some defects. Now, let's look at the direct drive, the pros. There is a short distance between the extruder and the feeder, so it's more aggressive. So you're going to have less retraction issues. Now, again, retraction is when the filament is pulled back up through the nozzle to get rid of stringing and blobs and print defects, which we're going to be looking at a little bit later. Now, the cons of direct drive, they're the opposite of the benefits of the other one, right? The extruder feeder, the weight of it, because all that motor and everything, or not motor, but the gears and the metal and everything, they're heavier. And since they're right on the hot end, right on the nozzle, they create vibration. And that vibration can screw up your detail. Okay, so now let's break down the parts of the actual extruder, the hot end. And this is what melts the plastic and extrudes it. And it's made up of a Teflon liner, a filament guide, a heat sink, a cooling fan, a heat break, a heater block, which in it is the heater cartridge and thermistor, and the nozzle. So let's break those down. So the Teflon liner. Now, some 3D printers have these liners. They're PTFE liners that can handle heat, and they help sort of keep the plastic cooler as it's moving through the top part of the hot end so we don't get any clogging or sticking. And it makes it easier to print PLA, but it also limits some of the temperatures you can use because you know the printer won't let it go too high, or you can actually damage that Teflon liner. Now, again, a lot of printers don't have that. Some do, some don't. Check with your manufacturer if yours does. Then we got the heat sink, and this is this big gray area. And what a heat sink does is it helps cool down. It helps dissipate heat. And you'll see almost all of them have this sort of grooved area to give it more surface area to dissipate heat. Again, what it's trying to do is it is trying to, at this point, keep this plastic, not melting, because it still has to get all the way down to the nozzle. And in that area is where it really needs to heat up and melt. If it melts too far up, you're going to get a gummed up printer. So all of this stuff, this heat sink in the blue area, is all made to keep that plastic at a temperature where it is not melted. Now, these next two, again, help keep the filament as cool as possible until it hits that sort of heated area that we're going to be talking at next. And this is the cooling fan. And so there's usually this cooling fan by the heat sink to help dissipate heat. And then between the heat sink and the hot end, there'll be a break, just some sort of dead space, again, to help with cooling so that heat isn't getting dissipated or isn't traveling down too much into that filament yet. Now, if we look at the real hot stuff here, is the heater block. And inside the heater block is the heater cartridge. And as you might guess, that is the thing that gets super hot. And then there is inside of this a thermistor, and it helps read the temperature of the heat block. And it's usually a small glass bead with 2 wires in it. And it's basically an electronic thermometer. And it senses how hot it is and helps it regulate temperature. Now, I have to tell you, this thing gets hot. Never put your fingers near this thing, and never put your fingers near the nozzle. Now, the nozzle is the tip of the hot end, and nozzles can go anywhere between 0.25 millimeter to 0.75 millimeter. You can exchange them, take them out and replace them. I actually need to do that on a couple of my printers. We're going to talk about why you might want to do that. But if you can guess, the smaller nozzles have a smaller opening, and therefore they extrude a thinner, finer bead of plastic. So you can get more detail prints that way. And larger nozzles, they'll print faster, but of course less detail. Now again, I want to reiterate, don't touch that. I have made this mistake. Oh, there's a little blob of plastic there and the thing is cooling down, and I'll go to wipe that piece of plastic away, just flick it away with my finger, and instead I brush up against this thing, which is 300 degrees, and then I get like molten plastic on me and a nice little burn. So just don't touch these. Use a spatula, use something if you're trying to scrape a piece of plastic away. These things get crazy hot. Now, if we look at the pieces of the printer itself, not moving away from the hot end, but the structure, we have threaded rods, and those will move that hot end up and down on the printer. There are belts that are attached to those stepper motors that will move the print head from side to side and up and down. All things that you want to check the maintenance of. We're going to look at that in the later videos. Again, we have stepper motors. And if we look at the picture to the right, we can see that the stepper motors also move that print head, that horizontal bar, up and down. That's also the frame. And behind the frame is those threaded rods we were talking about that move with the motor, that the motor moves the pieces up in a threaded motion. Now, next we have a power supply, and the power supply is built into the control box. If we look at that image on the right in the bottom, that's the control box. So inside that is the power supply that supplies, you would probably guess, power to everything. And inside our control box, we have a motherboard. It's a standard sort of computer motherboard, for 3D printing. And again, this is something that is kind of the same on a lot of 3D printers, but can have its own little differences. Then we have a user interface, and this can be a couple different things. Most printers that you're going to get now have a knob like to the right, and that helps you control the interface. Move the dial, and it moves a little cursor, and it you can select your thing. Printers also now are more and more coming with LCDs. So I have got one printer that uses a knob and two other printers that use LCDs. It's really something I think that most 3D printers are going to be going to the LCD method from now on, because it just looks fancier. And although I have to say I prefer the knob, they're more responsive. And lastly, how do we get our models into the 3D printer? We use one of these inputs. There's usually a USB input that will allow you to connect your computer. So there's that USB, and most of them come with a micro SD, so you'll need a micro SD card. And we'll go over some of the things, little ancillary things you might need for 3D printing in later videos. Actually, and some printers now are finally coming with, yes, the USB to connect your computer, but they're coming with a standard USB, so you can just use a USB stick. I love those because they're so much easier than having to keep track of little micro SD cards. So there you go. The pieces, parts of a 3D printer. And if now we look at this, we can see where the hot end is, where the different stepper motors, the drive feed, the control box, where everything is, the belts, how the printer is put together. And next videos we're going to take a look at are, how do we use this now? How do we feed plastic through here? How do we get a good print? And then of course in later videos, how do we make those prints look awesome? So in this section, we're going to talk about the 3D filament that we use in our printer. So it's really the first time we're not talking about the printer itself, but the material that we use to print with. And we're going to be looking at these various types of filaments. We're going to be looking at ABS, PLA, PET, PETT, nylon, flexible filaments, and then we're going to touch a little bit on specialty filaments. Now the first one we're going to look at is ABS. And you can see it's a very long scientific name there. I'm not going to try to pronounce that. But if I was going to give it a try, I'd say acryli. No, I'm not even going to try. I'm going to stop right there and call it ABS. And You can see that we look at the average price of this stuff. Most filaments fall around here, $15 to $20, $25 for a 1 kilogram spool. Now, all filaments also, depending on their type, ABS, PLA, will have different print temperatures. So we can see that this print temperature goes anywhere between 210 and 250. And the print bed temperature that it would recommend would be 80 to 110. And you definitely need a heated bed with ABS. Now, that's the thing. All of these plastics have different properties, right? They're a different type of plastic. So when I say the print temperature is 210 to 250, the manufacturer will tell you in the box, it'll give you a little piece of paper, and it'll tell you their recommendation and settings for both your print temperature and your print bed temperature. Because just like there are different types of plastics, there are different manufacturers that make ABS filament. So manufacturer A might say their temperature is 210, and manufacturer B might be 225. So always read the paper that comes with it, or it might be it's just printed on the box, to see what you need to set your settings to. And again, we're going to be looking at how to set all those things up later. Now, what are some of the attributes to ABS? It's a very strong plastic, and it's very impact resistant, and it makes it really popular for appliances, toys. Again, these are out in the real world too, not just us 3D printing. It also has a high melting point, so that's good for builders that are working with something that needs to take a little bit of temperature. The next plastic we're going to look at, PLA, has a lower melting point, and if you were to say leave it in a hot car, it would definitely warp. There's a great video on Punish Props over on YouTube where one of his props warped and melted, and it was very sad. Now, printing ABS is a little tricky. Because it has this higher melting point, it needs to be a really warm, controlled environment. Now, if you remember looking at that printer that we showed earlier, it's just an open box, right? It's an open plate, and there's no walls surrounding it or anything. Now, ABS requires a consistent temperature. So if you were to just try to print this on a heated bed and just print away with it, it would probably start coming apart. The layers would not fuse together because it would get cooler the farther it gets away from the bed. So having a box built around your printer, an enclosure, that is needed to print ABS. I've tried to print ABS just on a heated platform. Didn't work for me. So I built a cheap little box around my printer using insulation, those foam insulation panels, and then it worked. But it was too much of a problem to deal with, so I just print with the next printer we'll look at, which is PLA. But what are the pros of ABS? It's strong and it's durable. It's somewhat flexible. I don't mean it's rubbery, but it's got a little bit of give to it, and it's lightweight. It is, of course, relatively inexpensive, like a lot of filaments. Now, cons, it is petroleum based, and it's non-biodegradable. So that's one thing you're going to be dealing with 3D printing, is creating some waste. It needs a high temperature to reach its melting point, which we talked about, and it needs to sort of be kept warm through the entire printing process. And some people will also complain that it creates unpleasant fumes and should have ventilation, and it really does. It definitely has a worse odor than PLA, and that is toxic. So you should obviously have, if you're printing extended periods of time, some type of ventilation. Now, let's take a look at one of the next ones, and this is probably the most popular 3D printed plastic, polylactic acid, PLA. Now, again, the average price, pretty much the same. It is $15 to $20, $25. It can be higher if it's a specialty one, which we'll talk about in a little bit. Again, they mostly come in the same sort of weights. Now, as you notice, the print temperature is 180 to 230. Now, remember, it has a lower heat and melting point than does or ABS, and it doesn't need the enclosure. So it's fine. You can just print it, and you just have your print bed. You should have a heated print bed. It isn't needed, but you're going to be able to have a lot more adhesion if you have that. Now, this is, again, the most popular filament for hobbyists and professionals. Unlike ABS, PLA has a lower melting point, so you don't need a heated bed. You don't need that consistent temperature throughout the enclosure. And it's not a petroleum-based product, so that it doesn't have that noxious smell, and it is a little bit, I guess, environmentally safe. Now, it also finishes very well, so you can sand your prints to get a really nice quality to the surface, and we're going to look at that later. But of course, there are some drawbacks. Let's look at some pros. We have no noxious fumes. It's easier to work with compared to ABS. Remember, we don't need an enclosure. It is also less susceptible to warping and coming apart, again, because we don't need that enclosure. It can get cooler up towards the top, and that's fine. And it's available in some pretty funky materials like glow in the dark and clear and some other things we're going to look at. Now, since it has a lower melting point, it can get a little gooey and clog your print nozzle. And it is also less sturdy than ABS. So if you're building something like a hook or something that's going to hold like a tool, you might want to look at an ABS, but there are ways to use PLA to get the same type of a print, which of course we'll talk about later. Now let's take a look at some of the other different filaments that you can look at. There's PET, PETT, and PETG, and these are polyethylene triphthalate. And they're, again, a little bit more expensive. We're looking at $20 to $25. Higher print temperatures, 220 to 250. And this is a stable plastic. It's harmless. And again, like PLA, it doesn't produce a bad odor. It's also 100% recyclable. And when manufactured, it's clear, but you can add colorants. You can make it a different color. It is also FDA approved and considered food safe. So if you're going to print something you're going to drink out of or eat off of, you would want to use one of these PET type of filaments. Now, what are some of the pros? It's strong and flexible and is biocompatible, so you can drink from it. Very little warping. It does not absorb moisture in the air, and it is FDA approved food safe. Cons, it's not an easy material to work with beginners. And nozzle and printer bed temperatures need to be fine-tuned for best settings. So again, this stuff is trickier. When you get more specialized, it gets trickier to print with. Temperatures have to be right on. The atmosphere where you're printing can't be too warm, too cold. So, if you need to use something like this, don't start out with this gigantic, huge print. Start with some smaller prints to do your testing to make sure you have all your settings dialed in. Then we have sort of a specialty one, carbon fiber. And this is pretty neat stuff. It is, a little bit more than the 15 to 20. I would really put that, my research had said that, but I kind of find it more along 25 to 30. And as you can see, a much higher print temperature, 240 to 260, and a much higher print bed. And carbon fiber filament actually contains tiny bits of chopped carbon fiber strands through it. And this offers very rigid and great layer adhesion. So it's going to it's going to sort of stick together well, the layers, and it's going to be a strong print because those carbon fiber weaves, bits and pieces are in the plastic. Now, the bad thing is, since these carbon fibers, bits and pieces are in the plastic, it will also eat away at your nozzle, that little brass thing at the bottom there of your hot end, because it will, it's strong stuff. So you should either have to then maybe swap out your nozzle at that point or use a hardened nozzle, which we'll take a look at later. Now, some of the pros to carbon fiber: very little shrinkage or warpage, right? It doesn't shrink after it cools. Very durable. You can print, I know people will use this a lot of time when they're going to print RC cars or things that are really going to take a beating. And it is, of course, like I already said, it's less susceptible to warping. Now, the cons of it are very abrasive to the print nozzle. A lot of these filaments that have little bits in it to strengthen it or to do something to it, make it different, will wear your nozzle down. So you should either clean your nozzle afterwards and give it a test print and see if you need a new nozzle. You probably do. If not, use a hardened printer nozzle in your printer all the time, and then this way you won't have to exchange it too much. But if you print with something like this, definitely going to need to switch your nozzle out if it isn't a hardened nozzle. Now let's take a look at nylon. And again, we're looking at a little bit more expensive here, $30 to $35. Again, a higher print temperature, 240 to 260. And nylon is very strong and durable, and it's used in many printer situations. And it's great for functional parts because it is so strong and durable. And when it's thin, it doesn't wear very easily. So it's good for things like hinges or moving parts where rubbing up against each other, it isn't going to sort of wear it out. Now, it's very sensitive to moisture, so print should be allowed to cure in a dry space. So if it's very humid out, it could warp the print and maybe distort the print, so you'd want to make sure you've got it drying in maybe an area that you've got a dehumidifier running. Now, nylon pros, we're looking at strong and durable. It's not as brittle as PLA or ABS. Again, remember we said it's a little bit more flexible. It's 100% of a thermoplastic material. And nylon can actually be remelted and used again without any loss of bonding. You'd have to make your own filament, but you could remelt it and reuse it. Cons, it has a high melting temperature and it breaks down and emits fumes when heated. So it's kind of toxic when heated or burned. So if this is going to be used in something that it could catch fire, which we hope it isn't, then it could emit toxic fumes. And it also absorbs moisture easily. So not only do you have to make sure that the print you've just made until it cures is in a sort of a dry area, but you don't want to store this stuff in a very humid area. Next up, these are cool, flexible filaments. And they have they're a little more expensive, 15 to 20, 25, 30, around that range. The print temperature is lower because it's softer, right? 210 to 230. You don't need a heated bed, but I would recommend one. And as you may have guessed, it's flexible and it's malleable like rubber. I mean, look at the little sneakers this person made over here, and you can see it's 3D printed. You can see the lines in it, and it's got a warp. He's moving around in them. So it's got a very flexible nature. Now, the pros with this stuff is, of course, it's highly elastic. The layers bond fantastically. It's durable. It doesn't shrink very much when cooled. And technically, you don't need a heated bed. I mean, it's awesome, awesome, fun stuff. The problem is it's fairly difficult to print, and it can extrude, clog your nozzle. Now, here's the thing. When we're feeding the filament through the feeder, if you remember the hobbed gear and the sort of feeder that brings it through there and pushes it, this stuff is like wet spaghetti. And it can get clogged very easily. It can get crushed. It can get pushed around and not fed through. And if it isn't being fed through and pushed through, then it doesn't work. Now, there are some extruder feeders and extruders that work better for 3D filament or flexible filament. So if you're going to be printing a lot of filament, make sure you check that your printer can handle it. If not, look and see how you can put some upgrades onto it to make it handle flexible filament. Now, let's take a look at some specialty filaments. And there's just tons of different filaments that are specialty filaments, more and more coming along. Wood filaments, like carbon fiber, it has little pieces of wood in it. So it actually even smells like wood when you're printing it because you're heating this stuff. Again, since it has little pieces of material in it, it could damage your nozzle. So you're more than likely going to want to use a hardened nozzle or go ahead and switch your nozzle out afterwards. But this stuff does smell like almost like a campfire when it's printing. Now, there's glow in the dark filaments, and you can probably guess what those do. They glow in the dark. There's also metallic filaments that have actual metallic powder in them. And here's something that's like a bronze that somebody used. And again, this will wear out your nozzle, so you're going to have to use a hardened nozzle or switch your nozzle out. But you can actually polish this stuff once you've printed it because it has actual metal in it. It's really fascinating stuff. And then there's even really super weird ones like this one over here I just found I thought I'd put up here. And this is a beer filament, and it actually has like hops or something or ingredients that are used for making beer. And when it I saw a video on YouTube, somebody used it, and when it of course is printing, it actually does smell like beer. Not good beer, but it smells like beer. Now here's the big thing: choosing the right filament. It really depends on the job. For pretty much everything I print, all of my cosplay stuff, I use PLA. It's super simple, it's super cheap, it sands beautifully, and it does everything I need it to do. Now, if you need something else, let's say I might be building a RC car for one of my videos. I'm going to go ahead and I'm going to probably try carbon fiber for the first time. I'm going to put a hardened head on there and I'm going to print with it, and I'm going to take it off and put a normal head on nozzle. So it all depends what type of job you're doing, the final print you want, to what filament you want. Just know they range in prices and they range in what they can do. In the resources section, I'll have links to a number of different places that sell filament and a number of different companies that make filament. So you can resource or reference the kind you want and do your research. In this section, we're going to take a look at how to get your files ready for printing. And we need to do something called slicing. And yes, we're getting very hungry, right? Looking at that. It's actually around noon when I'm recording this, and that is making me hungry. And I think I will have some pizza for lunch. Now, what is slicing? Now, slicing is done using a piece of software that will read your CAD file, whether it's in Fusion 360 or Tinkercad or whatever you're using, or if you actually just find something online and download it, and it will slice that file into layers so that it can be printed, because right, we print in layers, and it converts it to a machine code called G code, and that's what the printer can understand. So for example, we've got a file, either an STL file, or we've made one in Fusion 360 and exported it as an STL file, or so for example, we have, say, Fusion 360. It's what I use. It's free to create a 3D design model. So for example, we could use a program like Fusion 360. It's what I use. It's a free application and very powerful. And you can create a 3D model and export it as an STL file. Or of course, you can just download an STL file from different websites. Again, you can find those links in the, I believe I'll be putting them in the final folder. So for example, you can use a program like Fusion 360, which is a very powerful program and free, to create really, really detailed 3D models. It's not an easy program to pick up, but once you do, it's incredible what you can create. And for that, you would then export the file that you've created as an STL, or of course you can download an STL. You then bring it into a slicer. And now, Simplify 3D is the slicer I use. We're going to talk about these in a minute, but this is the program that looks at that STL file, that looks at that 3D model, converts it to G code, slices it into G code layers. Then that can either be exported, that G code, to a mini SD card, which we looked at when we saw what the printer parts are, or it could be connected to your computer, could be connected to the 3D printer, and you can just print over USB from something like Simplify 3D. And then of course goes to the printer and makes our little owl. So that is what a slicer does. It takes our 3D file, it slices it into layers, converts it to J code, those layers, and then sends it to the printer. Now, there are a ton of different slicers out there. This is not all of them. It's just some of the main ones that people will use. The two main ones people use are Cura, which is free, and Simplify 3D, which is pay, and it is fairly pricey. It's $150. And then, of course, we go down the line to other different free ones. And, you're probably wondering, why do I pay for a slicer, right? Because $150 is a far cry from free. But I find that I have more control over the print. I can set some really finer details in. There's different ways to set up different printer profiles so that one part of the print gets one type of infill, one part gets another. Again, you might not know what I'm talking about. You will as we go on to the course. But I find it to be a much more sophisticated program. Then again, I know people that do this and print, are prolific printers and create amazing prints, and they use Cura. So when I started, I used Cura, and then I wanted to try Simplify 3D, so I did. So my recommendation would be to try Cura first, and then, of course, go and maybe, if you want, you don't have to a pay version of Simplify 3D. Now, links to all these will be in the resources section towards the end of the course. So why pay? I find I get a better prints and better control from Simplify 3D. You can talk to 100 people that say that they get the same thing out of Cura. It really comes down to settings, and we're going to be looking at that, of course, as we go through the course. Now, I talked a little bit about G-code and how these printers spit G-code out. Let's take a little bit. Now, I talked a little bit about G-code and how these printers read G-code that are converted and spit out by our slicer. So let's take a little look at what G-code is. Okay, so why pay for the slicer? Again, it's really, I don't want to say it's subjective because I know a lot of people who say that Simplify 3D offers much more control and you can get a better print from it. I feel that way. I also know a lot of people that think the same about Cura. So I would try Cura first if you're getting great prints, which you will. I've used Cura. I use it actually for one of my printers because I do get better results from it. And that might be because I just don't have Simplify 3D set up properly for that printer. There's a lot of little tooling and fooling around you can do. Of course, we're going to be looking at that later. But you might be thinking G-code. He mentioned G-code. I don't know how to code. I always got a kick out of this guy. Don't panic. That's what we use those slicers for. The slicers convert and make the code. But still, let's take a look at what G-code is. So let's talk about what G-code actually is. Now, G-code is the programming language for your 3D printer, and it stands for geometric code. And why it stands for geometric code is because G-code's main job is to tell your 3D printer extruder, the hot end, how to move in a three-dimensional space, right? We're talking about a 3D printer. Now, the code just doesn't move the print head around in a 3D print, but it controls the speed of the printer, the infill, how much plastic is fed, and even how hot the printer bed gets. So it converts that model into a language that controls every aspect of that feeder. So each line of code really equals each line of print and how the printer will run. And now you'll never actually have to do this. There are some people that will look at G-code to see if there's errors in it or whatnot, but you probably will never have to unless you want to. But let's take a look at how to read G-code. Now, if we take a look at a line of G-code at the bottom here, each line starts with G1. That's how it's going to start, every single line. Then if we look at this string, it says X. This will move the extruder along the x-axis 8.1 millimeters, and so on. Y moves it 4.262, and Z moves it 0.4 along the z-axis. So this is what we're talking about in a three-dimensional space. The G-code will tell the head to move up, down, back, and forth. Then we have the F number, and that stands for the speed at which the extruder moves. These are all settings that you make in your slicer. Not so much the movements, but the speed. And then lastly is the E, which is how much filament the extruder lays down on the print bed. Now these last two are things that you can change in the slicer, and when we start doing that, you'll see how different settings then exported as G-code will affect your print. But remember, you don't have to actually program in G-code. The slicer will do that. If we remember, we have the STL file. It gets spit over to the slicer. It's 360, Cura, whatever. It makes it G-code. Now we kind of know what G-code looks like. There's that little bit of code down there. And then it spits it over to the printer, and the printer will print. And that's it. That's what the G-code is. Again, your slicer does all of that. And then you either send the G-code to the printer via a USB cable with the computer connected, or you will save it or export it to a SD card or a micro SD card and put that into the printer controller box, hit print, it reads the G-code and makes your little owl or whatever you're printing. In this video, we're going to take a look at layer height, a really important idea and setting when you are trying to get a really high quality print or you just want to knock something out pretty quickly. So what is layer height and how does it affect your print? Now, as we know, our models are built one layer at a time, and how high and how thick these layers are will affect the quality of your print. So you could think of layer height as the resolution setting for a specific print you're making. And of course, the finer the print, the longer it will take, because if you are using, if you look at the bottom, a 0.4 millimeter nozzle, you want to shoot for a really fine print would be a 0.1 millimeter. Anything below that, it really can't handle, and it might actually cause problems. So 1.1 millimeter is extremely fine, a lot of detail. Your lines are very tight together, very small, very thin. You move up into 0.2 millimeter is average, and 0.3 millimeter, it starts to look a little rough. Now, if you're doing some sanding though, and you're gonna, like I do with a lot of my prints, I will usually print something at around 0.2 millimeter because I know I'm gonna sand it anyway to get rid of those lines. I very rarely will print something 0.1 millimeter. Sometimes I guess if there is a lot of detail in it, some statues, but most of the time, you know, 0.15 or 0.20 is what I'm going to print them at. Now we're talking large shifts in time here. If you're printing something, and we'll go to the next one, at a 0.1 millimeter, if you look at the one on the left, you can see just how thin those lines are and how tight they are. There's a lot of them. This is going to increase your time quite a bit. Now look at the one all the way on the right, which is like a 3 millimeter. There's, I can't even count them because my eyesight, how many of the 1 millimeter lines will fit in there. I'm sure, well, there's math that'll easily do it, but you can see just the amount of time that this could take to put all these little lines instead of those thick lines. Now those thick lines show up more. So if you're doing something like little models or miniatures are big right now, people are printing a lot of little D&D miniatures, you're going to want to use these smaller settings like a 0.1. Just know that it's going to increase your time quite a bit. In this video, we're going to take a look at brims, skirts, and rafts. Now, what are these things? They're kind of similar, at least two of them are. Let's take a look. Now, first we're going to look at skirts. And a skirt actually doesn't touch the print at all. They only surround the print, and they don't even help with adhesion, but what they do is they help prime the nozzle so that yeah, right, so that filament is coming out before it starts your actual print. You might have maybe a little under extrusion going on, or maybe the nozzle is jammed up a little bit, and this will help unclog things, and unless you've got a serious clog, and get the nice flow of filament going before it goes to the print. And you can see here from these images from a Simplify 3D website, it just travels along the outside and it just gets that nozzle ready. It gets the filament flowing, so it's ready to go. Now, brims are, you know, sort of a cousin of the skirts, and they actually it's really an extended skirt, and it will start at the outside or the inside, and it will travel, and it does connect with the print, the outside of the print there. So this will help with warping. It does help a little bit with adhesion, but the thing with this is it does not go underneath the actual print item, the model. So a brim just really is one layer, or you can make it more, that will help a little bit with adhesion. It doesn't go under the print, just up to it. Now, rafts are really the best thing to use if you want to get really good adhesion. And this is really just sort of a lattice work that will go down on the print bed and up a little bit, and many layers you set it to. In Simplify 3D and other slicers, you can set multiple layers and how they crisscross. But what happens then is your print itself is sticking to this lattice, this plastic, instead of the print bed. So the raft will go down very slowly because it's really, getting some good adhesion. And then when it reaches the height that you've set, the model will print on top of it. And due to its crisscrossing nature and the fact that it's the plastic itself that you're using, the filament, the model will stick to it much better. So I use rafts extensively. The only times I don't really use a raft if I've got a really long print area that's on the bottom, that's sort of there right on the bed. If it's something that's really thin or very narrow, I'm probably going to use a raft so that I know the item will stick to it. If it's got a flat bottom, actually see these images here from Simplify, I probably wouldn't even use a raft for that because the surface area on that bottom is so much. But if it was a thin model or something that like a tube or something that was tall, especially that could be moving back and forth, a little jiggling, I would definitely use a raft to sort of lock it in place. And here's something from my CR10. If you look on the outer edge there, you can see the brim going across, and then of course that big area is the actual raft itself that now the print will start printing on. And so, of course, this does use plastic. All these things use plastic and therefore, of course, take time. Brims, very little time. Skirts, very little bit of time. Rafts can take some time, depending, of course, too, on how many layers you set your raft to. But for the little bit of time, trust me, they are well worth it. I have been printing things, and it's a very large helmet, let's say, and I said, oh, I don't need a raft. It gets to the top of the helmet, and there's a vibration that's been going on for days, and all of a sudden it pops off, and it's because it didn't have a raft to really adhere it. So use a little bit of time, experiment with your rafts on your heights and how long you want it to take, but definitely use a raft. I would also use a brim because I love priming the nozzle, so it's a nice thin bead when it's starting the print. So use these things to really help keep your prints on the bed. Okay, in this section, we're going to start looking at different things you would set in your printer's slicer, whether it's Cura or Simplify 3D or whatever you use, that would affect the print quality or the print speed. So this is almost like a terminology section, but it's also a setting section because it's, different things you would set to change your printer around. And some of the things we're going to look at are right here. We're going to look at infill, thickness, retraction, print speeds, all these to see what changing one of these things will do to the print. So first thing we're going to look at, like we said, is infill. And infill is really simple. It has to do with how much plastic is filled in to the center or between the walls of your print. So you can see at the diagrams below, we've got the first one, that would be considered zero infill. You just have your perimeter shells. The second one, I'm not sure what the level of that would probably be, like maybe 20% infill, and it's using a honeycomb pattern. And then lastly, you would have the one that would be 100% infill, because you can print these things with 100%. Now, of course, the more that you do, the higher you go with your infill, the longer it takes. So if I'm going to do something that I know isn't going to get a lot of wear, let's say it's a statue that's going to sit up on the shelf, I'm going to go with a much lower infill. I usually only use about a 10% infill almost on anything because it's just so much plastic you're going to use, and it is such a time suck. It takes up a lot of time to fill things in, and it uses a lot of plastic, and it ends up being a waste. So there are different types of patterns. There are honeycomb, there's triangular, there's wavy, there's just straight sort of articulation where it's just going back and forth. You can choose. Some are faster and slower than others. I tend to use the normal one, which is rectangular, or what is it called? Rectangular? I cannot pronounce it now. Rectilinear. That's it. And that one is got a good speed, and it works just fine. That isn't to say that the honeycomb one doesn't look cool, and sometimes some people think it has more rigidity to it and more structure to it because of its shape. So here are two images that are using different types of infill. We've got one on the left with the gears, and that's using a honeycomb infill, and that's what that would look like when you're doing a print. You've got this infill set up. And then on the right, we have some number 5s, and you can tell that those have 0% infill. There's no fill in there. It is just the side walls. And that would be if you were doing something like a vase or something like a piggy bank or a test print that you didn't need it filled. Infill is necessary to give the part rigidity and strength. And if you don't need that, if it's something like this, you're doing a cookie cutter, then you don't need it. But infill is really important. If I can really drum anything into everybody, is that watch your infill. You don't need to put 30% infill in things, 40% infill, because it's going to use a ton of plastic, and filament is expensive, and relatively expensive, and it's going to take a lot more time. So start low, start at 10%, and see if the part has enough rigidity for you. If not, bump it up maybe 15%. But remember, use infill when you need it, but don't use a lot of it. Okay, so let's take a look at supports and how they hold up your model and when you might need them. Now, I saw this really interesting thing. I'd never really heard of it before, but it was a man named Joe Larson, a maker named Joe Larson. He called it the YHT rule. And I thought it was really great because he's saying that if you're looking at a piece or a part, if it's got these shapes in it, not a Y, a letter Y, but if like it's a model standing there with his arms out or her arms out in a Y, sort of like they're at a V up over their head, that would need supports because, as it got to the part where there was no base, there's nothing to print. Your print would fail. Or something like an H that has that kind of support where, or that piece where you've got one side that's got a model, has an end to it, and another side, but there's a span where there's nothing. And of course, a T, same thing. We've got a vertical structure, and we've got, just this bar across the top. Think of that same model, a figure standing there, arms at their sides, straight out. There's nothing there to be holding those arms up if you look at the diagram there. Now, there's a couple different types of supports, and we're going to look at supports in greater detail in a later video. But if we look at these three images right off the bat here, we can see there's from the build plate, and that's going from the glass or your build plate, your bed, from the bottom of it to the print, so it meets the print. Then there's just the print itself. There's no supports on the bottom, and there's no supports on top, obviously, but there is a support structure in the middle of these two pieces. Those ribbed lines are supports. And then, of course, there's just supports everywhere. So you set it so that it will go from the build plate, it'll go from inside the part, everywhere. And again, if you don't turn supports on for pretty much almost all prints, I mean, unless you've got like a cylinder that's just literally like a cylinder with no overhangs, you're probably going to need some type of support. So again, we're going to talk about these later. They're, sometimes it kind of stinks to have to print them because they use plastic, obviously, they take time, but If you don't print them, your print will fail. In later videos, we'll take more of a look at them, and we'll also have some videos on how to position your prints so you need less supports, which of course will take up less plastic and less time. The next thing we're going to look at is shell thickness. And again, this is something that you will set in your slicer that will affect the quality or the structural integrity of your print. And as you see in later videos where we set some of these things, you'll see right where it is and how it affects them. Now, shell thickness is the number of shells or outer walls that your printer will lay down in the inner part of the print. Okay, shell thicknesses also is one of the sort of biggest factors in the strength of the print. There are a lot of videos, and I've watched a lot of videos on this. Again, some people say it's shell thickness is more important than infill. Some people say infill is more important than shell thickness. And it comes right down to, and I'll put a link in this section, somebody did a fantastic video where they tested every permutation of this you can think of. And I think he came up with the thing that it was shell thickness. So you can see that the bigger image on the right is pretty much what we're talking about. They're a lot closer together, but the number of shells, the number of solid shells that it starts to do before it does the infill, that's your shell thickness. Again, if I'm doing something that I know is going to take a lot of beating, like maybe something type of a club like Thor's handle from Thor's hammer, I might do that with multiple shell thicknesses because I know I might be swinging that around and it needs to be thick, it needs to be rigid. And that might even be more important than the amount of infill that I use, because again, we're sort of swinging it back and forth, and if the outside is flimsy, then it doesn't really matter how much fill is inside, it could still crack. So shell thickness, play with that. I usually set it anywhere from 2 to 3, usually around in the 2 area. If I'm going to do something that's going to be taking a lot of wear, like maybe a hook, I'm making a hook for my wall for tools or something, I probably will bump it up to maybe like 5. This way it's got a lot of rigidity. So shell thickness, really important. Now this setting, retraction, is one, I think, at least in my opinion, that I've had the trickiest time dialing in with my printer, sort of getting the right settings, because it has so many different contributing factors to it. Now, what am I talking about with retraction? It's when your print head moves from the span or across the span of one piece of your model to another. Okay, so as it leaves one side, it goes to the other, and you can get some stringing to happen. And I'm actually just going to go right to the photos because it'll show them a lot better. So I turned retraction off pretty much totally for the one on the left because it's just terrible. And you can see as it leaves one side and goes to another, the plastic is still hot. Obviously, it's always hot. And there's a little bit of bloopiness, that's a technical 3D term, on the end of the print head, the nozzle, and as it moves, it strings over, and this is the stringing that you get. And you can see some really fine stringing over on the right, even though that is not between 2 areas. I guess technically it is because there's different little pieces and parts in that one thing on the right, like supports, but I've got that machine dialed in a little bit better, and that doesn't usually happen all that much. Now, why I'm saying this is tricky is it can be a number of different factors. It can be, do you have your filament too hot? So if the manufacturer says 115, do you have it set to 130 because you think it goes through your nozzle better? If it's too hot, hotter than it should be, it's going to sort of be obviously hotter. It's going to be more molten. It's going to sort of collect more at the bottom, and it's going to be susceptible to of the nozzle, and it's going to be susceptible to the stringing. Now, also, again, if you have retraction settings off on your slicer, and we'll look at those in later videos, if you don't have those on, you're going to get this. This is no retraction in Simplify 3D. And you'll get this. Now, the retraction settings, they're different for every printer. There's speed, there's how much it goes up through the nozzle. There's many different things that work in the settings for retraction. And again, in another video, when we just look at the Simplify 3D settings for retraction, you'll see how many there are. But dialing in your retraction settings is key to really getting some nice prints, because it's going to use less plastic, very minuscule amount. But again, when you're going through rolls and rolls, you want to save as much as you can. But all this stuff you've got to clean off. You got to scrape, you got to sort of break that off, and then you've got to sand it even more. So always make sure you look at your retraction settings. And again, in later videos, we're going to get into more of how to make these settings work better for you in your slicer. So another setting in your slicer for your 3D printer is print speed. And that doesn't have to just do with how fast the print happens. Now, of course, that's one of the main things it does. If you set your print to go to the maximum speed that your printer says it'll do, you want to look in the booklet to see what to set that to, or check out different message boards or Facebook groups to see what people are using. Yes, you can make a print go faster. You can shave a couple hours off of a print. But here's the thing, it also affects quality. And we talked about this before a little bit. If you set your printer to its highest setting or even faster, what's happening is it is moving that heater, that nozzle, that printer head fast, and you're going to get some vibration, you're going to get some shake, and that is going to cause defects in the print. So see what your printer's max speed is and then go a little bit below that, because yes, you might save a couple hours, but in the long run you're going to get a print of lower quality. Okay, so like I said, I use Simplify 3D, and here I am at the Simplify 3D website, and it's got some testimonials from some of the big guys in 3D printing. And of course, the 3D printing nerd right there, Joel, and what is his name? Oh, it's right there. From Angus, from Maker's Muse, and these guys are from Adafruit, Fantastic Electronics, the hot end, a lot of people. So if you're interested in the software, it does come at a price. It is $149. So it's obviously a lot more expensive than, say, Cura, which is free. I find that I have much more control over it, and I get really, really great prints from it. There are people that will say that they get great prints from Cura and wouldn't spend this money. That's just me. And, well, a lot of professionals who do this. So again, I would use Cura for a while, and then if you are really getting into 3D printing, this is something you might want to check out. The cool thing about this is once you start up here, you have an account, and then you can go ahead and download the software for either Mac or PC or Linux, whichever one you want. And you control your installations here. Unfortunately, you can only load it in 2 machines. That's normal for most software. I'd like there to be more, so I can sort of have one in my office and one downstairs. And then let's say I'm at work and I want to fool around with something, I can do that. But you can also deactivate and reactivate it wherever you want, which is something I end up doing. So you can buy another license, but it's an additional $150, which I think, let me make sure, yes, I think should be much cheaper if you've already bought one license. So that's really cool, and you get constant updates, and I've never had a problem whenever I've had a question. It has a huge community because a lot of people use it, and I've really just enjoyed using it. So that's what you would do if you wanted to get this. You'd go to their site, you'd buy it, create an account once you buy it, and then you can install it. So next thing we're going to do is we're going to skip over to, we've already installed it, and we're going to look at setting up your preferences and machine settings. Okay, so here we are in Simplify 3D. Now, the first thing you want to do when you're working with any kind of software is to go to your preferences and take a look. So we're going to go up here, and I'm on a Mac, so your preferences might be in a different place. I think it's over here somewhere like under options or something on a PC, but over here it's under Simplify 3D. So let's take a look quick. I am running the latest version of 401. Again, if you buy it, you get obviously free updates. And if I click on preferences, I'm given a list of things that we can do here. So we can either set up between millimeters per minute or millimeters per second. Some people use either one. I tend to just leave it at millimeters per minute. But if you're looking at someone else's settings, see what they have it set at. They might have it at a second, and then you might have to do a conversion or change this. These are just some basic ones where you can swap your mouse wheel. save and restore application state. I would keep most of these. I've never changed these, to be honest with you. So I would just go ahead and keep these at a normal sort of default method. Now, machine settings, these are very important. And when we set up our first profile, you'll see how this gets populated right off the bat. So you can ignore this for now, and then we will go ahead and look at that later. What you will notice, it'll say machine type. Is it a rectangular build, or is it a delta, which is the sort of the circular model? It talks about your build volume, how big your heat bed is, or your printer bed is, how offset you want it from that bed, the honing directions. Again, most of this stuff, or all of this stuff, is basically set up when you choose your process, or I'm sorry, your profile. Next we have models. This has to do with the model that's on the print bed. Again, I've never really done a lot with this. You know, I keep this checked, automatically center, because I just wanted to center, calculate normal independent form from imported file. These are just good to keep at a basic. Now, these I have had to fool around with sometimes. I was working on an older machine at one point, and when it was a very complex model, and when it went into preview mode, so these are the preview settings, it couldn't handle it. So I actually had to change this to low preview detail. So if you've got a slower machine, you might need to do that. Everything else I've pretty much just kept the same. This hides the actual virtual build plate, the virtual environment. I would keep that. I really enjoy that. And this changes the colors of your model. So the default color of the model will come in like this orange color. If you select it, it goes a brighter orange, and the support material looks a little red. Now again, you can click on here and you can change that. Again, I've just pretty much left those normal. Network is something I don't usually use. I just go ahead and run the program without any sort of network configuration. You do not need to be connected to the internet with this to use this program. It's not a web application, but you do need to have, obviously, internet connection if you're going to download any updates. So that's pretty much it. Those are your preferences. I've left, I would say, 99% of them basic default and not changed a thing. And again, when we set up our profile, this right here will automatically get populated. So I'm going to go ahead and OK out of this. OK, and that's it. That is how to set up your preferences in Simplify 3D. Okay, so we've already looked at the preferences for Simplify 3D. Now let's go ahead and add a printer. Super simple to do. You go up here to Help, to Configuration Assistant. One thing you might want to do though too is check for updates before, and it's good. We are up to date. So then we go to Help and we go to Configuration Assistance. And why you might want to check for updates before you do this is it adds new printers every so often, or quite a bit. So that's nice to do in case there's one here not listed. One time it would be there after you've updated. So I am going to go ahead and add a CR10. I've already got a CR10 profile in here, but I'm going to just do another one for this video. So I'm just going to go CR10, going to hit Next, Finish, and there you go. It has added that profile into the system, into its profiles. So now you can choose, and we're going to look at this in a little bit more detail, but you can use this now, and you go over here, and there it is. This is what we just added, the CR10. And you could literally just go ahead and print right from this, make some basic changes, and be ready to go with this profile. Now, there are many different ways to tweak this and change it and make it so it's more specified to a specific model you're trying to print. We're going to look at that in the other videos as they come up, but that was it. That's how simple it is to add a printer. And if you've noticed, when I go to profiles, there are other profiles in here. So you can have multiple profiles in your instance of Simplify 3D. And let's say you're going to print on an Anycubic, you select that one. Let's say you're going to print on a CR10, you print on that one. So really, really simple to use. Okay, now that we have a model loaded in Simplify 3D, let's go ahead and take a look at the interface. I wanted to wait till we had a model loaded because a lot of the interface has to do with how you manipulate a model and get it ready for printing. So let's go ahead and step through the interface so you know where everything is. Now, we've kind of looked at this one. This is the models panel, and this will list all your models that you have loaded. Now, when I'm referring to a model, I'm talking about the figure that's on the print bed. And you can import them here. You can remove them. You could click center and arrange, and you can see it just sort of popped. I'm not sure if that's Leonardo, but I'm gonna call him Leonardo from now on. It just moves Leonardo over into the center. So this has to do with your models. Down here are the processes, and processes have to do with how the software is getting the file ready to print. So you're setting everything up, you're setting the process of how the file will export to the printer and what it's going to do. What is the size of the file? What's the info? What's all the specs that'll make it print? That is the process. And you can add new processes, you can delete processes, and you can, of course, edit a process. And we're going to look at all that as we go along. There is the prepare to print button, and when you click on that, you probably guessed it, it prepares the file for printing. We're going to go through all these things in much greater detail. I just wanted to go over the main interface so we can take a look at what we have here. Now, there we are on the left side. Let's take a look at the right side where a lot of the tools are. Now, of course, here you've got your arrow so you can select things if you want. You can also click on this, and this is the translate model or sort of move tool. So once I have that now, I can, let me sort of tip this so you can see what he's doing here or what I'm doing. So I go to translate, and now I'm moving him around. Now again, you can hold down your option on a Mac and you can move them around that way too. So you don't have to use some of these if you don't really want to. This is scale. So I can click on him, and as I move to the left or to the right, I can make him bigger or smaller. And this is literally how you could make, actually I'll keep him this big so we can see him on there. This is how you can make a model much, much bigger. Now you're going to use a ton of filament unless you were careful. And we're going to go, oh, that made him really big. I forgot I had scale selected. I'm going to move back to that. So again, we're going to look at how to set, you could actually print this and not use a ton of filament. So we're going to leave him this big though so we can take a look at him and see how he looks on the print bed. So there we go. There's that. Then we have the rotate here, and this just moves him side to side or, 360 degrees, however you want to do it. And of course, this also works by clicking on the command will also rotate him. Okay, now these next two have to do with sort of manipulating the movement of the print bed, the virtual print bed. So if you click here, that's the default. That's how it loads with a point here and a point there. This is looking at it from the top, and you can see how these are shaded. So the top is shaded, so we're seeing it top down, from the back, from the side. Again, I'm going to tell you, I think those are literally the first time I ever clicked those, because all you have to do is hold your right mouse button down and just move around, and you can do that a lot simpler. So that is funny. That I think that is literally the first time I used those. Now here you can see your X, Y, Z, and axis, and that's turned on. If you don't want that there, you can turn it off. I find it helpful though, so I leave it on. I think that's literally the first time I've turned it off. This next one here is the solid model, so it shows the model. If you click on that, you can't see the model. You turn it back on, you can see it. This is the wireframe. So all 3D models are really just made up of hundreds and hundreds or thousands or millions of triangles. And when you hit that wireframe, you can actually see all the triangles. It can get a little annoying, so I usually turn that off. And a lot of these things are also up here. So you can view, see the default, the top, the left, the solid model, the wireframe. You can do all that stuff up here as well, but of course it's usually much easier doing it right here. Okay, the next thing we're going to do is look at this one right here. This is the cross section. I find this one really interesting. It will show the cross section, as you might have guessed, of the model. So as we move the up the x-axis, we can see how the model gets put together over, as it's printed, which is really fascinating to see how it was sort of put together and built. And then you can of course turn that off and you can see it a little bit better. So that is the cross section. This is the machine control panel. Now, I don't use this a whole lot because I just have it connected to the printer, or I save it to an SD drive. But this is how you can connect to your printer by clicking on this. It can get a little tricky sometimes if you're trying to connect with a Mac. You need to download some specialty software so it will find it easily. This isn't something I usually fool around with a whole lot, but it is helpful for me. How I use it is, let's say I'm printing something and something goes wrong. If I click on this, I can click on this emergency stop button and it just stops everything. But it also will show you sort of, where the positioning of your printer head is and the temperatures and everything. But I set that up in the preference, or in the settings in the process, which we're going to look at in a second. Actually, not a second, probably the next video. So let's look at this next one here. This is the support structures. And we're going to go into much greater detail with supports because they are super, super important. But this is how you can generate supports, just to see where the supports would be, and or to make it that way when it's printing. So I'm just going to do a quick one here. If we just go normal, the base, which most printers can handle, and I click generate supports, it puts supports in where the overhang or the angle is, or there's nothing there, so it needs something to build up on, that it will print. So for example, say this hand. If you're printing this hand is just floating in mid-air. So the print head would be going up here, it'd get to here, and it'd just come here, and it would just sort of like bloop, plastic out right here, and you would get a mess. You would get a failed print. So supports build up so that when it gets to here, it starts printing the print on that support. So we're going to look at much greater detail in the supports in another video, but that is pretty much the main interface. We're going to be looking at the process interface and things like that, but moving around, this is what you do. Again, I usually will use my mouse and just push the left and right mouse button down to be able to make these, make the model move around and do what I need it to do. I use these controls here and here. Sometimes I will go up and use some of these, but they have to do with things that aren't over here. So for example, let's say, and a lot of them are in edit. Let's say you wanted to copy a selection. You can select this and you can go to copy. Now, of course, you could just do Command C if you wanted to. So I've just copied that. And now I can actually come up here and paste it. And I've got another one. So you can see it says Teenage Mutant Ninja Turtle 1 and then the second one. I'm just going to remove that. And there's some more controls up here that we can do that we will look at as we move into some more of the videos to come. But that's it. That is the interface of Simplify 3D. Really simple program to use. I've been trying not to say that since it's called Simplify 3D, but it is. It's very simple. So let's go ahead and import our first model into Simplify 3D. Now you can do this a number of different ways. You can go to the menu here and go File, Import Model, or you can do Command or Control depending on what system you're on, Mac or PC. I usually just click on this little guy right here that says Import, and then you will choose your model. So I'm just going to grab something from a friend of mine, Yuri, and let's grab this little Teenage Mutant Ninja Turtle. And there he is. Cool thing about Simplify 3D, and I think a lot of them, they drop them right on the bed, and I'm clicking down on my mouse, on my right button, clicking and just spinning. Okay, now if you click your left button, it goes up, down, left, right. And if you click down on your left button and use your scroll wheel, you can move him backwards or forwards. So that's really handy to be able to move things around really simply and easily. It's one of the reasons I really love this program. So let's take a look. We've got our figure here. This is our virtual build plate. Okay, this is the build plate, let's say, of the CR10, which is the machine we're using, its height and its dimensions. So you can see we can get a lot higher with this figure if we wanted to. And if we look over here to our models area, we can see that the Teenage Mutant Ninja Turtle figure is right there. It's model number 1. Now we can remove him, and we can also arrange him to the center. He already is. That's where it usually will drop him, but that's it. That's how you do it. That's how you import a model. Now, if you wanted to import another model, very simply, import. Let's add the keychain version of him. We open that up, and you can see it puts it right on top of that, right? Because it drops it right to the center. So we click on center and arrange, and now it put him right behind. And you can see it's got a little keychain version. And this is what's called a low poly sort of STL or low poly figure, because it's not really smooth. It's all nice and angular and really kind of cool looking. I think I'm going to print that, actually. I think that's kind of neat. Print a series of them. So that is it. That is how you add one figure, multiple figures. Now, let's say you wanted to select one figure and not the other. A couple different ways you can do it. Remember our color scheme? This is the default color, and then this is the selected color. Now, if I click on him, he is now the selected one. And if you look up at the top here in our models, that is selected. So you might have guessed it. If I click here up in this menu, now he is selected. And that is how you can select both either model. Now you can actually go up here and do Command A, and it will select both of them. So you can select multiple figures if you want to move them around or whatever you want to do with them. Now, speaking of moving them around, let's look at just how to move them around with your standard mouse area here. So if we click on this and we hold down the Option, we can spin the turtle on the x-axis. Okay, and we can see the x-axis is right here. If we hold down the Command, we can move him along, and the mouse, and I'm just dragging with my mouse. I'm clicking and I'm just dragging him wherever I want. So that is how you can easily just sort of move the figures around. And let's say you don't want him over there, you can just go ahead and click center and arrange. Now you might be saying, why do I want to do that? Why do I want him just in the center? We're going to look at what you're going to do if you have a lot of stuff on this bed and how you can actually organize things so it might print a little bit faster. Okay, so that's it. That's how you add a figure or multiple figures. Actually, while we're here, let's go ahead and remove one. Let's say we don't want to do the keychain. We can click on it and we can also hit remove. Now there's one other way I didn't show you how to get a figure in. You can actually drag a file right here onto the bed and it'll populate it. So you can either import here, you can import in the file menu, or you can actually just drag and drop a figure. That's it. Importing figures into Simplify 3D is super simple. So we imported objects in a previous video, but let's take a look at how to arrange objects, how to arrange models or pieces of the model on the actual print bed. Now, we had the turtle at one point, and it was just a single object. So what do we do when we have multiple objects in a model, which will happen a lot of times? So I'm going to import by clicking the import there, and I'm going to pick up the file that it doesn't have a ton of stuff, but it's got enough in it. And you can see all of these files. And this person, his name is Yuri, he does a fantastic job because he actually puts like right here 4 times, meaning you need to print 4 of these. So I'm going to bring all these in. I'm just going to select all and import or open. Now, this is interesting because this goes back to our preferences. We uncheck that thing that automatically set the size, because sometimes sizes are a little bit different. Maybe someone's creating something in a different country or whatnot. So it's saying here it would be extremely small in the inch format. Would you like to automatically scale it to millimeter? You want to say no, or you'll have a huge, huge piece. So we say no, no, and here we have it. And it might look familiar if you're a Star Wars fan. This is, or an old school photography fan, this is Rey's lightsaber. And you can see that it comes into the print bed pretty perfect. What we want to look for are areas where are we wasting a lot of filament? Does it make sense that this object is placed that way? You can see cylinders, these are going to print straight up. You're going to have very little, if no, support material. These are very low, very little support material. And they're all tightly packed together, which is good, because what will take, another thing that'll make a print take longer is when the printer has to zoom all over the print bed. So keeping things close and tight can really help save print time. So for example, let's see here. We've got supports on and a raft. Let's hit prepare to print. And depending on your model, how many pieces you've got here and the speed of your computer, this could take some time. So this says it's going to take about 21 hours, which really means 36, because it's all these programs are just terrible in getting your times right. So 21 hours though. If I were to take this piece right here, and I'm doing command, and I'm going to move it like way over here, and I'm going to move this piece over here, and I'm going to move this piece over here. I mean, this would just be, you would never want to do this. And this piece here. And now I'm going to hit prepare to print again. Takes a little bit of time, and you're going to see a difference. So 21 hours, 54 minutes. So we've almost added an hour to our print. And really, again, when you're adding, if you add an hour, you're actually adding probably 3 or 4 hours, because the software just isn't really good in calculating true time. Now you might think, oh, big deal, an hour. But again, if you're printing something that has even more parts, and this says like 67 hours, or if you're doing a print with even finer detail, you could increase your time exponentially. So key is to just keep everything tight. And I'm just doing Control Z to put everything back the way it was. And now we've got a nice tight print setup. But what happens if, and I'm going to do a Control All and then just remove. What happens if we try to bring something in that there are too many parts, that seems, for the print bed? So let's go ahead and bring in Yuri's Amazing Optimus Prime. And you can see here lots of files. And some of them are 2 times and 4 times. So I'm going to do Control All again. I'm going to open. And wow, right? That drops a lot of files down. So here it's saying we can't get these pieces to print because they're off the print bed. It would not work. But here's the thing. These things don't need to be lying flat like this. So best thing to do, and this is, let's say if I was actually going to print this, you're going to look for flat surfaces that can be stood up. So right off the bat, these can definitely be stood up to save some space. Now there's a couple different ways to do that. You can double click on them. Let's see, we'll find the chest, and what's this one called? The back and the chest. And then we can come over here to our rotation and set this to -90. And then we can hit center and arrange. And you can see here that they're now up and down. They're vertical and not horizontal. And doing that to all the pieces that could be stood up will save us a ton of time on the build plate, or a ton of space. So let's look around here and see what else we can do. Now, all these pieces here have a nice flat bottom. So we could select all of them. Let's see where they all are. And I think that is all of them. Yep. And oh, I deselected them. So they're all right there. And we can go -90. Oops. How about just 90? And center and arrange. And you can see that now, nice flat bottom. We're not creating a ton of support material, just in this little space right here, maybe a little bit in here, but we're starting to really save space. Now, there's some other ways to do this too, where we're not using the control panel. I like to use that, but there's a way that can be even a little quicker when you're doing so many models like this. You can go up to your menu, and go to place surface on bed, and it's Command L. So now you can see as I mouse over this, it highlights this piece, and if I click, it just drops it straight down, which is nice. And then if you just do Control L again, and I'm just doing Control L, and clicking, you can see all these pieces that have nice flat bottoms are dropping down to the bed. Let's see, this one definitely work like that. And where's another one I saw over here? Drops that way. And we're just trying to give us the most space that we can. And these have a little bit of a, oh, these are nice and flat, or they're kind of flat. So we're going to make sure we pick the bottom that has the most surface area. And you can see they're tilted a little bit, so we might have to tweak those. And I'm still doing just the Command L and then clicking. And oops, I accidentally clicked Command L, so I'm going to do Control Z. Let's see. This right here, I might make a little bit more support material, but not too much. So I'm going to do that. I'm also going to do it on the bottoms of these, although that's probably going to create quite a bit of support. Well, it all depends what you're going to go for here. Do you mind using a little bit more support material, or do you want to try to get it all on the print bed? That's not a ton of support material, and it's pretty low. So I'm going to go ahead and leave that. Okay, now let's zoom out and do center and arrange. And there you go. Still need to do some tweaking. I don't like to have things so close to the side. If I don't have to, I'd like to try to keep it all sort of a little bit more tightly packed. And one way we can do that is we can click on that and we can set the rotation to 90. And then we get this chest piece and we can set the Z rotation to -90 so that it will sort of be a back-to-back type of thing. Okay. And I'm just moving things around by doing Control and pushing down on the mouse, dragging with the mouse. And I will move these so they're more away from that print bed edge, but still close to each other, because remember, the closer we keep things, the better. These two are way too tight. And I've printed things actually like right up to the print bed. But again, keeping it all fairly tight makes things print a little bit quicker because they're closer together. The print head doesn't have to move around. So there we go. We have fit all of those models onto the print bed. Now, you're probably saying, yes, some of these say 2, 4, and well, you know what? I might be able to. So, okay, let's see if we can do this entire model. So this says I need 2 of these. So I can do 2 different things. I can do Control C, Control V, and I've just copy and pasted. So now we have 2 of those. We need 2 feet. This is where it's going to get tricky. Control C, Control V. So I've got 2 of those. Oh, this is definitely not going to fit. Oh, wait, no, shoulder joint, this one. I do a Control C, Control V, so I've got 2 of those now, and I've got 2 of those because I had that selected. Now, let's see. Can we make... Yeah, I think we can. I think we can. This is just got to get moved over here, and then I will rotate it. And I think that ball joint's fine. That foot... This is going to get moved. Let's see. Let's rotate this and move it in. Let's move this guy here and this here. And you know what? This one shouldn't be like this. Let's rotate this 90 degrees. This is where it gets a little tight. I am going to have to move these things closer to the edge, but that's actually fine. And then I'm going to rotate this back this way and bring it here. And that should allow me to put this right in there. And I can move this a little bit if I need to, and that. So there we go. We actually did fit everything in ×2. And we've got the print. Now let's go ahead. Now here's the other thing you want to do after you do something like this. Go up here, File, Save Factory File. And we'll name it Optimus and total. And we'll save that to the desktop. So that factory file is the thing you then launch. Like, say it's like a Word file almost, right? But it's has this all set up. Our process has everything set up. So I don't have to do that again because I don't want to do that again. We'll come over here, and since this is a model, I'm going to print it very fine. I'm going to do it at 1%. Infill, I'm going to give it probably more infill than I usually do because I want it to be kind of solid and chunky. Actually, I'm going to go ahead and give it 50 because the pieces aren't very large, but they, I think with a little bit of weight to them would be nice. And I've never printed this, and I think I actually might. So let's go ahead and do print process, or prepare to print. And this has got a lot of stuff on it. So this could take a few minutes actually to render. Most times 30 seconds to 45 seconds, a minute tops. But this one's taking a little bit of time, and I'm not going to edit this. I want it to go in real time so you can see how long something like this could take, because sometimes you might get a little antsy. You might try to click prepare to print a couple more times, or you might, like hitting that elevator button. And that is just going to make things get screwed up, and it's going to want to go back and do it again. So just give it the time, and it will happen. Again, the faster your computer you're on, the faster it'll happen. So here we go. Now remember, I like to have this set to feature type, because then it shows me all of the information right there. I can see where the supports are, where, okay, I'm not using a ton of supports. Since everything's so tight, I don't have anything overlapping. And you can actually see how my computer's lagging right here as I'm trying to view this preview. And that can be bad, because if your machine is really slow, it can really have a hard time chugging along with this. So if you are having this problem where it's just really slow and moving like that, you can go up to your preferences and go to visualization, low detail, because really you don't really need high detail in the visualization. And we hit OK. And I would need to actually reload this for it to work. So I'm going to hit prepare again. And using that lower visualization will make things move quicker. I've actually had some really complex models on the board, and it has told me it cannot preview it. I need to go in there and do that. So I usually set it to be at low visualization right off the bat, low detail. And you can see it's actually going a little bit faster because it doesn't have to render the detail of this preview. And now you can see it moves a lot faster. So you might actually always want to have it set to low detail. And this thing says this is the drawback of this type of thing which we just did. Yes, you can fit that much on here, but at the ultra finest detail, this says it's going to take 221 hours, which means like 400 hours, because the higher the number gets, the longer the miscalculation takes. So that is crazy. And all that would have to happen is you'd be printing for like 3 hours or 20 hours or 100 hours. And because you have things so tight, and maybe like one file just doesn't like to be printed that way, it fails. So while you can do this, I would probably argue against it right off the bat. I would do I would break this up into maybe 3 different prints, and they take a couple hours, like 20 hours a piece, 40 hours a piece, but then you're not losing tons and tons of time. Now, we did set this to a crazy high detail. Let's say we set it to 2.5. We cut this fill down to a sort of a normal level. We hit OK. We hit prepare to print. You're going to see a much different time here. Now, again, the detail in the print won't be as sharp. You might have to do more. You definitely have to do more sanding if you want it smoothed up. You can see we just went to 60 hours, which is about 72 hours probably. So huge drop in time. But we did go from, 1 almost to 3. So you really you lose detail, but you gain tons of time. If you're not in a hurry, go ahead and do that. So there we go. We've added things to our print bed, and we've manipulated them a number of different ways to increase how much we can fit on the bed. Now, do you always want to put this much on the bed? I would say no. If one piece fails to print, then you've lost everything maybe above it. Now, if it failed right here on this, that'd be great, right? Because really you've only lost this piece and these higher pieces. Everything else would be fine. But if it failed here, you've just lost hours and hours of printing and pretty much every model on the board. So take your time. Don't pack your bed this much, and you won't have very long prints, and you can protect against failing. So there we go. We've just loaded tons of stuff on the print bed. Okay, in this video, we're going to take a look at the process settings. And those are all the settings that go into Simplify 3D, telling the printer how to actually print out our little Leonardo here. So if we go over to the processes, we can see if we double click on process, we can edit. We can also click down here to edit process settings. So I'm just going to go ahead and double click on this, and it will bring this up. Now we have here our profiles, and of course these are our different printers. So there's a CR10, there's a different Creality printer, and there's the Anycubic i3 Omega printer I just love. And this is how you can easily just switch these different printers. Like, oh, I want to print on the one on an Anycubic, or I want to print on a CR10. So you can easily do that. Now, let's say you had another FFF file, another profile, and FFF stands for Fused Filament Fabrication. You can go to File, and you can go to Import Profile and import one. Now, how would you get one of those? A lot of times if you buy a printer, I would highly recommend going, looking on Facebook to see if there's a user community. And so for the CR10, there's a fantastic community, and they have many different profiles that people have sort of tweaked and created for all the different printers. And actually that Chris's Creality is a very good CR10 profile that he has come up with from tweaking different settings around and getting really good prints from. So that's actually the one I use as well. So that's another way you can get those profiles. So let's say we wanted to not use the Creality CR10 one, but I wanted to use Chris's. Now I could click on it, and it's going to say, do you want to save changes made to the CR10 one? That's the one we just brought in. I'm going to say no, because I really didn't do anything to that. And now you can see that it is set up for Chris's. And we can actually save this as a new name if we're going to make changes to it. I'm not going to make changes. I'm just going to keep it like this. But let's say we knew we were going to change it dramatically. We could do save as new, and we could name it Chris's Creality 2. And then this way we'd keep this original profile safe the way it's supposed to be, and we'd have a backup. But I'm just going to leave it right now to Chris's Creality. So let's look at some of the basic settings that are in the not advanced area, but this is just the basic thing we can see. We can choose to auto configure the material. I usually print with PLA, so I just have that selected. And then we have auto configure for print quality. Now, fast can be really messy, and it's fast, but you're not going to get a really great print out of it. But if you just want to test it to see how it looks, that's a good way to do it. It takes less time and less filament. Most of the time you'll be printing on high. Now, if we hit high, we can see it did change how much infill. And then it also included a raft, and it generated supports. So these you'll usually always keep checked, and then you can change your infill. Now, we learned earlier what infill means. 0 means it's hollow, 100% means it's a block of plastic. I usually keep mine, depending on what it is, usually around 8 to 10. If it's a piece that's going to get a lot of handling, maybe it's a mask, something like that, I would usually bump it up to maybe 25 to 35%. And this is the basic settings. There are much more advanced settings, which we're going to look at in a second, but this is how you would switch your printer profile and do some basic printing. Now you could go ahead right now and set this to medium if you wanted to, or back to high, and go ahead and click OK, and it'll be ready to print right off the bat. We wouldn't even have to do anything else. But there are ways to tweak it to get an even better print, and we're going to look at that next. So we are back with our turtle to look at some of the advanced settings in the process menu. So we're going to go ahead and add a process, and let's take a look really quickly again at the basic settings here, those sort of presets. We can choose fast. You can see it sets 10% infill, medium goes to 15, high goes to 30. And it's also changing a bunch of stuff. If we click on advanced, it's changing some things in here that will affect the quality of the print. So, for example, if we go to layer, high is 0.10 millimeter height. It's got 4 top solid layers, 4 solid bottom layers, and 2 perimeters. So that's where it sets it at. Now, your first layer settings are I set mine actually at 120 and 150. These you could go down a little bit. You could set this to probably 110 is what I think I usually had it set to, and this 110 as well. There we go. And your first layer speed, I like to keep that pretty slow. Sometimes as slow as 30%, just because that first layer is the most important. That needs to adhere, it needs to stick, it needs to be nice and smooth. Let it go, let it take its time. So these are some pretty tight settings to get a really, really smooth print. Now you could add, and there are some models that I do use more top solid layers and more bottom solid layers just to give me even a better quality. Again, every time I use the word better quality, tack on time, because more quality, more time. And if I'm doing something that's like something's going to hang on, or even a helmet that could take some banging if I'm putting it in a bag or whatnot, you might even want to go to more perimeter shells. But for the most part, you can get away with these settings here to get a really, really good print. Now, infill is something that I don't use a lot of. I think it can be very wasteful. There's almost no reason to print something way up in here unless, again, you need a solid piece. I usually stick anywhere between 8 and 10% infill, especially for small pieces, even medium pieces. That's a lot of plastic. And again, it takes time and it burns through your filament. Now, additional additions here, this is where we're looking at the skirt and the brim. And I usually will leave a skirt, about 2, and I give it 2 layers for the outlines, just because, let some of that filament come out, let it play through, might as well. And then this way it's ready when it's really starting to print. Now your raft, again, I like to use a raft when I'm printing anything that isn't sort of flat on the bed, because that raft is going to help things adhere. And that is key when you're doing 3D printing. You don't want something falling off. You don't want something coming loose. I do end up tweaking my rafts to 2 and 1, because I just, I don't need that many rafts going on here. Now, this is another important one, separation distance. And the higher the value here, the easier it's going to be for the raft to actually come away from the plastic or your model, because if it's too hard coming away, it's going to leave marks and you're going to have to do a lot of sanding. So I usually set this to 30. but it might be different for your printer. But usually these types of things are relatively the same. We go to infill. Again, we've chosen 10%, but we can choose different types of patterns. There's the reticular, the grid, the triangular, all these fast honeycomb. I usually leave it as the default because it seems to work fine for me and it's pretty fast. We can then fool around with the interior fill percentage, okay? And again, these are things I usually keep pretty standard here, and this, like it says, determines the interior solidity of the model of the actual infill, and usually these are totally fine with me and I leave them as is. Now there's some other things that you can change as far as the angle that they go, but again, I've never had a problem with these settings. I would just leave that. Now if you need supports, click on supports, or you can click up here. And we've looked at our different support settings when we were using the tool over here, where we can either go with the resolution or we can change the overhang. We can make it either from the build plate or from there. There are some really powerful things over here though. And the thing that I want to show you, and again, I usually leave these at a default. One of the really great things that's new is this right here, support base layers. So sometimes if you have a support that can be kind of thin and it's just sort of like this tiny, maybe like a 1/4 of an inch square of plastic on the bed, that might kick off. But if you can add a support layer to your bed, that will then, the support will then adhere to much more rigid and much more secure. This I always make sure I have on if I have supports on, because I definitely want to make sure my supports don't fall, make sure they don't go away. Now I can set my settings here for my temperature, and again, this has to do with the manufacturer's settings for the filament. Sometimes you might have to tweak it depending on where you're printing. Maybe it's a basement, it's cold, and you want to bump it up a little bit. But you can add or subtract these. Let's say you needed to change this to 220. You double click on it, type in 220, and there you go. Same thing with the heat bed. Let's say you want to go 65, which I usually do, and you go to 65 and it's there. So you can change them. You can add different ones if you have different extruders or multiple extruders, but these work really well for me. Cooling effects, the fan. Again, at the first layer, the fan is usually off because you don't want any sort of a breeze moving that filament around. And then at the second layer, it jumps to 100. You could, at a set point here, at say layer 2 at 60 and 3 at 100, just so you're giving it even, it's ramping up slowly and it works that way. So that's kind of nice that you can do that. And here's some the G code, and I don't usually tweak with this at all. It's our machine settings is set. We don't need to mess with that. Simplify 3D does all the slicing, so I usually stay out of my G code. I also don't really do a lot with scripts. One thing I will fool around with sometimes here is the speed. You can increase this printer speed, but you want to take a look at what the max speed of your printer is. And remember, yes, we've got this on high. We've got more detail going on with our layer height. If we increase the speed, even to like the max that the printer says it'll do, the faster it goes, the more that head is sort of vibrating and it's jerking around, and that will cut your quality a little bit. So if the printer says it'll do, 60 millimeters a minute, that's pretty fast. And you might want to take it down to 52 so it's not going too crazy and causing problems. Other has to do with bridging and filament properties. Again, I leave these default. You can change them if you're having some print problems. Most of the time, though, the defaults were set there for a reason. In advance shows your layer modifications like we looked at earlier. Where is it stopping? When is it starting? Your thin wall behaviors. Do you want to leave a gap when there's no space. So like this one right here, interior thin wall type. So in the interior of it, if there's a thin wall and maybe there's no filament being laid down in there for whatever reason, just how the model's built, you can choose this, allow fill gap, which is default. And if there is a little space in there that's not being filled, it will, put a little bit of a infill in there to cover that. The other thing you might want to look at too is your ooze control. And I usually will leave this totally the same, but I do change this and I click perform retraction during wipe movement. And that helps when it's doing the wipe movement, it retracts it up into the filament, up into the, not the nozzle, but the hot end to keep the ooze away. Now, in looking at that, let's jump back over to our extruder and take a look at retraction. This is a huge thing that you want to look at when you're printing. And we looked at the retraction, all that stringing, we don't want it. Again, you can set it the default, it's on. I usually always click on coast at end and wipe nozzle. Again, this is going to take more time, but at the same time, it's less sanding. So, I'd rather just let the printer run and not have to do much more sanding. So I change that. Now, the big thing here is your retraction speed. Again, look and see what the highest that your printer will do and set it to that. But you want to be careful when you're setting things too high in your retraction, because this will cause the nub, the nub on the motor to be moving back and forth, pulling the filament and pushing it and pulling it, and it could actually snap the filament. So I usually keep it at the default because it's a safe setting, and I will increase my speed up to what my printer can do and leave it at that. And then I don't get the stringing. So these are some settings you can use to make better prints. If I had to pick the key ones, it would be work on your retraction. And I can tell you to set this, and I can tell you what some of the numbers are, but it's going to be different with the printer you have. It's going to be different with the filament you have, maybe the temperature in the room. So you'll need to tweak these, but just know they're there. And of course, this right here, your layer settings are key. The higher the number here, the less quality. Same thing here. Actually goes different in reverse here. The lower the lower quality here with lower numbers and strength. So I usually keep these at about 4, 5, 4, 2. If I need to have something, like I said, with more strength, I will jump up the perimeters. Now, a lot of people think I have to have 100% infill for it to be super, super strong. There have been a number of videos I've watched, and you can go on YouTube to find those, where they will use like a 10% infill, but they'll use, 8, 7, 5 perimeter shells, and that actually gives it a lot more rigidity. So that's something you can actually play with, or just go on YouTube to see some of the other videos people have posted and talk about that. So there we go. That's how to really increase the quality of your print. At the same time, if you don't want that, if you want to do a test print, which I do often, I will go to fast, and you can see it just jumped everything. It didn't change this, but it usually sets these to 1, 1, 1, 3, and now everything is just, it's going to look pretty bad, but it's also going to go a lot faster. So remember, just like anything, when you increase the quality or you increase the infill, you're going to make it take a lot longer and use a lot more filament. When you decrease the quality, layer height, 0.3, it's going to go a lot faster, but it's not going to look as good. So it's a trade-off. But most of the time, I'm not in a hurry to print these things. So I let them print and I tweak these settings. Again, you will have to tweak these for your printer and for your filament. And that goes for anything, not just Simplify 3D, but also for Cura or any other slicer. So there we go. Let's say goodbye to Leonardo. Okay, I was going to use the Spider-Man model for this next video, but I thought this would be a little bit more apropos. What we're going to look at is multiple processes. And that is where we have, you might guess by the word multiple, a couple different processes here. So let's say for this entire model, we've got these settings. We've got I'm going to set this to a 10% infill. We want this to be fairly detailed, even though we remember what this is going to do to the print. If you remember correctly, it's going to make it quite detailed. I'm going to set it down to 1.1. Then we're going to say, yes, all these things are fine, 10% infill, and there we go. Okay, now, here's the thing. Looking at this model, there are some really cool things about this model, actually, is that it can be articulated, it can be moved, and that's using these ball joints. These ball joints go into pieces like right here and over here, and you can actually move the figure like you could an action figure. Well, here's the thing. That means these pieces here take a lot of stress. So it might be good to have them filled even more. So I'm going to select everything by using Shift Select. Whoops, that's the wrong one. That has a ball joint on it. I think it's just these. This, and I believe that's it. And every time I spool it, I'm losing my selection. So, okay. So there we go. Now, we learned this earlier. I'm going to make a group, and I'm going to call this group solid. And there we go. So now we know that these are all going to be solid. Now, yes, it's going to make this piece solid too and the whole thing, but it's not that large, and it'll be cool to give this thing a little bit of weight. More I fool around with this model during these videos, the more I'm thinking I'm going to print this. So now, again, we still have one process setting. This is all going to be 10%. It's all going to be 0.1. So again, we wanted to make these solid. So let's go ahead now and add another process. So we come down here and we click Add Process, and I'm actually going to rename this Solid. So we know I'm going to take this to 100% infill. So these will be solid pieces, since we know they're going to get a lot of wear. And I probably don't need as much detail, so I'm going to bump them to 2. Yes, it will make those those 2 other pieces 2, but that's okay for now. So we hit OK, and then we have 2 processes. Okay, so now we're going to go ahead and specify which part of the model is solid and which part is process 1. So since not a lot of them are solid, we'll do that one because it'll be the easiest. So we double click on that to bring up our process, and remember this is 100% infill. We go to Select Models, so it comes up and that's all of them. We don't want all of them, so we do Select None. And we go to Foot Ball Joint, right, because we need the ball joints, and then these 2 ball joints. Now, unfortunately, it doesn't list them as the solid group that we made. That would be really nice. But take note of which ones you need to go into this process, and then select them and click OK. And then we click OK again. And now just these pieces will be solid. And let's take a look at that, and let's slice it. We'll do Prepare. And then what it's going to ask us is, which process do you want to do? And we want to do both, right? We want to select all because we want to print this whole thing. Now you could choose to print one or the other, but we're going to print both. We hit OK, and we just hit yes, because this is just for test purposes. Okay, so then we see the G code, our preview here. And we've got it set to feature type, which I like because it shows all the breakdown. And now let's zoom in on one of these ball joints. And we'll bring this all the way down so we see it before as it starts. And if we look at the ball joint, we can see that every print, this print here, has got whatever infill we set it to, maybe 10%. This has got 100%. You can see there's no sort of gradual infill here or honeycombed infill. It is a solid piece, same as this one right here that we set up. And that those are the only solid pieces, and everything else has got this infill. So that's using multiple processes to really save you a lot of time, a lot of plastic, and to make parts specialized to what you need them. Remember, these are going to take a lot of wear. They're 100% infill. They're solid pieces of plastic. These, we didn't need that. So separate processes saves you time and saves you money. Okay, now in a previous video, we looked at how to have different processes for different models. Like, let's say there were 5 models on the bed, you can have a different process for each one. But with Simplify 3D 4.0, you can actually do multiple processes in the same model. And this I do a lot with helmets when I'm doing test prints for helmets, because I don't know if this is going to fit me. So I need to do a test one. Well, these helmets can take 90 hours, 70, 80, 90 hours. I don't want to test it out that way. So a great way to do this is to use the multiple processes. So what you do is, I've got my helmet here, right? The right orientation that I want it. And I go up to my menu area and I go to Tools, Variable Settings Wizard. And it brings this little control panel up. You see the little red line here. And as I move this, it'll move up my print. Now, I know that I want this to pretty much end right about here. And why am I doing this? Now, a helmet, again, I want to try this on. I want to see if it fits me. So I need a process that will set the bottom part to have more fill, to be more structurally sound. So when it prints the stuff up here, it'll be able to hold it up. And this way, this is using more material and this is using a lot less material because this is going to hold this up. So I go ahead and I add a location. So it just added a location at this point. You can see it turned bluish gray, and I can add more if I wanted to, but I only need the one. So I click Split Process. So now I've got a process 1 and a process 2. If I double click on process 1 and I go to Advanced, I can see that it starts at 0 and stops at 60.84. So that's here to here. So I'm actually going to rename this Base, because sometimes it can get a little bit confusing. And in this one, I'm going to name Top, because if we go over to Advanced, we can see that it starts at, actually it's ending there for some reason. We're going to have it not end there. We're going to end it no ending. It keeps going up. So it starts at 684 and it ends when it's over with. And I named it Top, and we click OK. So now we have a base and a top. So now we can go in just like we have before and click on Base. And again, we're going to set this to fast because we don't care about quality here. We just want to make it print. So I'm going to turn off or bring it to 3.0. Top solid layer, we only need 1. Bottom solid layer, we only need 1. And the outside shells, 1. Again, doesn't really matter. We don't need a skirt or a raft. Infill, that we're going to put at 10. Again, give it a little bit of a little infill so that it can actually have some rigidity. So because we're going to try this on, we need to make sure that it fits. We are working on the base, so we do want support material because it has to be able to cover the base to hold it up, the sort of the shape of it. And I'm going to increase the size a little bit to probably 60 because we can have more of an overhang down there. And at this point, I am ready to go. So for this part, so I hit OK. Now the base is done. Remember, this will have more infill, this will have less. We double click on Top, and I don't need 15 there. I actually need 0. I don't need supports. Now we had them before, right, in the eyes and everything, but this is so thin now and so light, you do not need to worry about supports. I'm going to turn off retraction. Again, I'm going to have my layer height here. I'm actually going to bump my shells up to 2 because when I've done this in the past and I've used 1, they're really thin to the point where they move on their own. So when I go to put them over my head, I have to really make sure that my head isn't sort of just like pushing the plastic out. Whereas if I give it 2 shells, there's enough rigidity there that I know it's really fitting. So set the fast, 0, everything. Again, quality does not matter. We hit OK. And now we're ready. We hit prepare to print, let it slice. But again, we choose top and base, just like we did when we were doing multiple on the same bed. We click OK, and there we have it. You can see it's 25 hours, and we've got just the right amount of support material here, and then none in here because we don't need it. It's super light. And if we look, if we zoom in here, we can see there is still some fill, right? Because infill is orange right here, and it's orange there. And then after we hit a certain point, we'll zoom out, there is no infill. It's hollow, okay? And then we just have the inner perimeter. And it just goes up, and it finishes up, and it's done. This will be super light, super fragile, but it'll be enough that it'll fit on your head and you'll know that it works. And then you can go for the 90-hour print for the really nice one. And this will save you a ton of time and a ton of filament. Now, other ways and models that you can use this on, really anything that you look at and go, wow, it doesn't need that much filament. It doesn't need that much infill halfway through it or most of the way through it. I think I mentioned before Thor's hammer. It's a big block of plastic. You could have more infill where there's detail to help with the detail. Then you could taper back on the infill, and then you can go back up and put a little more infill in as it gets to the other end where there's some detail, and save yourself a ton of time and a ton of plastic. And that's just by using the variable settings wizard. Again, you need 4.0 for this, but it is a hugely and amazingly powerful feature that I used quite often. Okay, in this video, we're going to take a look at how to manipulate, add, and how supports work in Simplify 3D, and how to actually, maybe tweak our supports and or have less supports, because again, remember, supports equals more filament. So let's go ahead and bring in what looks like a simple model, but really isn't. And this is a helmet. And helmets are awesome to print. They look really cool, but they can be a bit of a pain. So this is the Red Hood helmet that you've seen in some of the slides. And this was done by Colonius. You can find his stuff over at CG Trader and all over the place. Thingiverse. Again, in the links below in the reference section, you'll see all his stuff. So as you can see, big, right? This is a big helmet. Now, first thing you're going to want to do is make sure this thing fits you. Usually you need to scale these things up a few percent. So I'm going to go ahead and do that. I'm going to double click on the model, and here's our scaling. And since this is uniform scaling is checked, when I move it up here, I move it up everywhere. And I'm going to bring this up to 105, just 5%. You can see it still fits on the bed. And again, this is set up to be the profile for the CR10. So we've got plenty of bed space. This is why you want big bed space. If not, you would have to have this chopped up and then glue it all together and really work on those seams. So something you might not want to do. So supports, how do they work? Now, we can take a look at our supports. If we come over to our side menu, there's this button here, and that's the support generation. Now, it always starts out pillar resolution at 4 millimeter. Okay, and you can see if you mouse over, it'll tell you, how much, it'll tell you what it is. So you can get a little reminder if you can't remember. And it'll also show you the max overhang. Now, most printers are 45%, and that means how much overhang can a model have? Like, how much can it overhang the edge before it needs a support. So I usually leave this at 45 because at this point I know my printer can handle that, and that's usually what printers are at. Now, your resolution, though, that you could change, and we'll look at that a little bit later when we bring in a more detailed model, because the more detailed model you have, the finer you might want this, or the lower the number. So let's go ahead and hit generate supports just off the, with nothing changed. Now, as you can see how this helmet came in, that is a lot of support material. The entire helmet is literally, you can see back in the eyes, the entire helmet is filled with support material, because remember, it needs it. It can't just print that in thin air. This is just floating. It would never, there's nothing there to hold it up. Hence the word support material. So that is crazy. You would use almost a whole roll just on the support material alone. So I'm going to say clear all. And this is where the last video sort of also helps out, and that's placement. So if I double click on this and I come over here, and let's say I move this to -90 and I center it. Okay. Now you might think, oh, okay, well, let's see what's going to happen here. We can keep bringing this down like this, so it's sort of even, and we drop it. And let's generate supports. But again, look at this. This is a gigantic, there's probably more filament being used in these supports than to print the helmet, because they're thin, right, and hollow. So not good. So you're probably guessing, let's flip it all the way over. So now we're going to do, I'm going to zero it out, and I'm going to bring it to 90. I'm going to center it, and you can see now it is on the dome of it. And now I'm going to generate supports, and very little, right? We got this tiny, bit down here, this much here, because again, this overhangs. So what would happen is it would get to here and there'd be nothing here if those supports weren't there, and it would just fail. And there's some inside. Now, that is going to take considerably less than if we flipped it around and did it the other way. Now, the problem is sometimes when you pull your supports off of here, you're going to get, especially towards the bottom, some banding and some really rough looking plastic up here. So it isn't going to be nice and smooth. And that's when you're going to want to watch, obviously, the sanding and the finishing to really get that to shine. And you'll actually see some examples of this actual helmet that I printed with a really rough bottom. But again, incredible time savings. So I'm going to hit done, and I'm going to set this to 1.0 because I wanted this, I remember when I printed it, really, really sharp and really, really, and actually I just saw this was at medium. Set this to high. I'm going to bring my infill down to about 10%. Hit OK. Prepare to print. Okay, so as you can see at 0.1, we're looking at 180 hours. That's a lot. But I'm going to go back, and I'm going to reset the supports. I'm going to clear those. I'm going to bring this back up to, I believe it was -72. Drop it to the board and prepare to print again. And let's see what it comes to now. Okay, now that is what I call, that is crazy. 616 hours because of all that infill material. Now, you would never print that. I mean, 616, that is a crazy amount of time. So you can see what positioning your print also can do with your supports, and how to use your supports in a way that doesn't cause so much to be used. Now, I would probably not print this at 0.1, only because I know I'm going to sand it and I'm going to do a lot of work on it. So I'm going to bring it to 0.2. I'm going to cut my infill down to about 8%. I've got generate supports, and I've got a raft, and I want a raft there because, there's just a tiny thing touching here. And I want, when it's starting out, to have a base to it. And that's usually what causes the damage. But again, we'll fix that later. So remember, I just switched this to 0.2. I'm actually going to bump it up to 2.1. I'm going to prepare to print, and let's see what happens. Okay, now we've got a much more reasonable time. And that's the type of time you're going to have when you do a large print like this. I mean, this is a helmet. Think of printing like a motorcycle helmet that's actually a little bit bigger than that with some detail in it. And that's what you're going to print. So we see our raft. We see our supports. And of course, it put a raft on the support, which is very good to help that. And then just a little bit on the inside here, so that it can hold up this little chin piece and all these other pieces. So again, watch when you're positioning your model, use the support generation tab over here to get an idea of where they're going to be placed and if you've got it situated. Now in the next one, we're going to look at how to fine tune your supports when you have a more fine detailed model. Okay, now we're going to get a little bit more into the fine details and how to sort of hone your supports a little bit more. So let's go ahead and import something a little bit more complex. And this is from one of my favorite movies, Chappie. And this is a Chappie model. And I'm going to bring in the head box, because as you can see, it's fairly complex. Got a lot of stuff to it. Now we'll do our little test here first, and we'll look at our supports. And you can see that's a lot of support material. And we're going to clear that. So I think right off the bat, let's go ahead and go to place on surface, choose this bottom part, and now we can see we're not going to need as much support material right off the bat. We're still going to need quite a bit because this is a fairly complex model. Now let's look at the support generation area here. What are our options? Now we could do normal supports, and if we generate them, they are coming from the print bed and not from the print bed, right? These are not touching the print bed, they're on the model. Now you can choose from print bed only. So I'm going to generate supports again, and now you'll see that they only come from here. Now this would not print because there is nothing here to support this part of the circle. The overhang is too great and it just wouldn't work. Same thing here. That's why you need that support everywhere. Now, why would you use something like this? Let's say you were printing like a bank or something that needed to be hollow, and you didn't, and it had enough material to actually, go across the beam here. You could then go ahead and do that because you'd never get inside of a bank, right? So for the most part, though, you will do normal because you are going to need support material where you need it. Now, let's take a look at our support pillar resolution. And this has to do with how thick and how chunky our supports are. And it defaults at 4. So I'm going to just go to high so we can see a definite difference. So I brought it to 8 and I hit generate supports. And you can see now that the supports have gotten a lot bigger and a lot chunkier. And let's go up even more. I don't think I've ever gone that high. And you can see how, again, really chunky supports. Now here's the problem. A model like this, it's very detailed and very fine. The more supports you have to really catch all these little overhangs, the better. And when it's this thick, you're just not getting the support coverage that you need at that fine of a detail to really give it that smooth sort of a look. So I'm going to drop this back down to 4. Remember, this was normal. And you can see also that some of the places that we have supports weren't even supported when we went too high of a resolution. So, there's really no reason to ever go that high, obviously. Now, let's go ahead and drop this down to 2.0. And take a look at the circle area. If I click Generate Supports, you can see how there are a few more added. And you can see how they're much more finely packed. There's more of them. They're thinner, but they definitely cover this much more smoothly. And the more supports that are in there at that higher resolution, the smoother that arc is going to look when it's printed. And if we went all the way down, I've never gone down to 1, we can see just how fine they are. And the same strength, and there's even more in here than before, but it will really give you that nice smooth arc. Now, that's, I think, overkill for this. I believe when I printed this, I printed it at a 3.0 because I wanted more in here and to get a little bit more resolution. I might have even printed it at a, let me look because I can probably recognize yeah, I printed them at a 2.5. You can go ahead and change that just because I wanted a nice, smooth and as much support in this complex model as I can get, because there's a lot of points of failure here if you don't have a support in a specific item. So there we go. I just went ahead and really refined our supports. Now let's say though that you are looking at a model, and for whatever reason, like you notice that you think it should have some more supports. You can do a couple different things here. You can add new support material. So let's go ahead and click. Let's look at this model. Let's say I'm going to remove something really quickly, and then I can add it. So let's say you notice that on your model, you're like, oh, all these are filled, but this one didn't fill. You can add support material. So you can go to manual placement, add new support, and as you can see, here's the support. If I dropped it right there, well, it wouldn't because there's nothing there. But now I go ahead and I place it in here, and you can see now there's a support there. And I can add some more supports in there, just like in the other areas. And if I hit done, now I've got a support in there. Okay. And that would work also if you came over here and bring our support panel back up, add supports. Let's say you were worried about this overhang, or you just wanted to give it that extra little bit of support because you're like, wow, this is a really complex model. I want to make sure every possible thing is covered here. You're now able to just add those supports to all these little pieces and areas. Like the printer says this isn't needed, but you could add all the supports you want, just in case. But a lot of times what I'll use this for is if I'm looking at a model and I really want to make sure I can shore up the supports to see and make sure that everything is covered. Now, another way to do that, if let's say I clear all the supports and I bring this down to 3, and now it's saying maximum overhang. Again, most printers are going to be maximum overhang that it can handle of 45%. So you can see how it definitely has things here because there's a bigger overhang here. Let's say you want it to be even extra careful because there's a lot of weird angles and jags in this print. I believe I set this down to 40%. So look right in this area here. If I click generate support, you can see how it's added supports in. And if I bring it down to, I'm going to go even farther, 30, it adds even more. So it isn't adding supports at 45%, it's adding them all the way down to 30. And this model is so sort of, it doesn't seem complex, but there's so many little jags and jogs that we can't really see very well, like in here and in here and these little spaces here, that I printed this at 35 with, I want to say it was a 2.0 or a 3, just to make sure that everything was covered. Did I use more plastic? Yes, but I wanted to make sure that all the overhangs were covered just in case there was a little shifting, a little bit of movement. And there we go. So use your lower resolution or higher resolution, I guess, lower number to get finer supports. You can go from the base down or the base up. And let's just give this a quick test and see how long this would take. And we're looking at 54 hours. So really about 64 hours, because you can always add 20 to 25%. And this was printed at, I had it set to at least of 2.1. So there we go. Using your support area here, you can definitely fine tune your supports to add more detail, to add supports, to remove supports, and get the most out of it. I'm of a mind to use supports liberally to make sure that every piece of my support or my print is supported. But play with it and see, because every print is different. You might set this to 45 and never have a problem. Really complex prints, I like to go a little bit lower. Then we're going to look at a really handy little function called the mirror mesh. And that's when you want to make a duplicate of things, but mirror them. And what am I talking about? Let's go ahead and import something that will show this off really well. It is a bookend. Not very useful by itself. It's a cool little Captain America one that I got over at My Mini Factory, I believe. So we've got this figure here. Now we need two of them. So we can do a couple different things, right? We can select it and we can go up here to duplicate. But since we only need one, we can just do Command C, Command V again. PC or Mac, it could be different. We can select both of these and move them to the center more, or we can hit Arrange Center. I'm just going to leave them the way they were. Now, again, kind of worthless bookends. I guess they could be, but you'd have to turn this way and you wouldn't see the shield on both sides. So we need to mirror it. So go ahead and select this one so we can see it really easily. And we're going to go to Mesh, Mirror Mesh. And if we turn this, we can see I guess we don't really need to turn it. We got our Z, our X, and our Y. So if we turn this, we know we want to mirror this on the X. And there it goes. It just turns over and we can see that it is lined up because we didn't really move it or anything. We could select both of these and move that to the center a little bit more. And we could even bring it a little bit closer, because remember, the closer something is, as long as it's not touching or it's not affecting its supports, the better, because the printer doesn't have to move around as much. So there we go. We have just bookended these two things, making it symmetrical and easy to print. Now, there might be one other time you want to use this. I'm going to get rid of these models, and I'm going to import another one. Okay, so this is a Batman tactical suit from DO3D, a really good site to buy different types of models. And when you buy a suit like this from them, they only give you one side. They give you a left or a right because you can mirror them. Why have, 70 files when you can have half of that? So, for example, let's say if we go to this shin piece, I'm going to grab the right one, this shin piece right here. So this is a shin, and again, this is why a good high and big printer helps. Now I would end up fooling around with this to make sure it printed a little bit better. The lean is a little bit too much. I'm just going to do this so we can see what we've got going on here. And again, we're going to get just this one piece because we don't need both when we can mirror. So I'm going to do a Control V, Control C, Control V. I'm going to align these. And this again wouldn't be correct because now we've still got two rights. So we select this, we go to Mesh, X, and now we've got the opposite, right? So here's this side here, here's this side. We have a mirror now. We have a left and we have a right. So sometimes you will get pieces that you'll be a little confused maybe, like why is there only one arm? And why there's only one arm is because why give two when you can just flip it in your slicer? And you can do this in pretty much any slicer out there. And it's really fast and really handy. So that's how to use a mirror mesh to make a mirrored duplicate of a model part. Okay, in this video we're going to take a look at selecting and grouping different models on the print bed, and we've looked at some of this in some other videos, but we haven't really gone into grouping, and this will actually lead us into our next video, which is going to be multiple processes. So these are some web shooters, if you're a Spider-Man fan, that I modeled in Fusion 360. So if we look at these, we know, you might not be able to tell from the model, these canisters go in here. So there's 1, 2, 3, 4, 5, 6, 7. This canister is to this one right here. So we need 7 of these. Now, yes, we can copy and paste 7 times, but remember, let's just go up and do the duplicate for this one. And we need 7 of them. And I'm going to do a center. So there they all are. And actually, we don't really, we'll go ahead and keep those on there. Why not? Because I think we can fit them. So we have all 7 of these. Now, if I select this one and I want to size them all, I've got to shift select to size them all, and that's fine. But if we also then want to add a specific event to each one of those, like a scale or an infill setting, we'd have to do it across all of them. So let's go ahead and group them. So I went ahead and selected them again on the board by shift selecting. Now you can also come up here and select and then shift select, but I like to do it a lot of times here, especially if things are in different areas on the list over here. Now I can come over here to edit and say group selection. And now I've got group 1 right there. And I can rename it. And I'm going to name it carts or cart. And those are the cartridges. Okay. So now when I want to select all of these, I just click one and it selects all of them. If I double click on them, I could come over here and I can scale, and you can see it's scaling all of them. So it's if you've got I just hit 10% on accident. If you, those would be Ant-Man's web shooters. Now, if you have multiple objects like this that are the same, grouping things really makes sense, because then you can easily change them, move them around, and do whatever you need to them. So that's it. That's grouping things. If you wanted to say ungroup this, you would select the group, go to File, go to Edit and Ungroup, and it just breaks them all out. I'm going to hit Command Z so that they're grouped again, because we'll be using this same model in another video. So there you go. That's how to select different things on your bed, group them, and ungroup them. Okay, so we learned a little bit about bed leveling. So let's go ahead and put that into action. So for this video, I'm going to be using this Anycubic i3 Omega. And what I'm doing here is I am bringing the print head home. And this is different on all printers, but look in your settings and it'll tell you how to actually send it home. And that's setting it to its home position where it starts out. And once it's there, what you're going to do is, in some printers, you're going to have to turn off the stepper motors. It'll make it easier for it to move. Then you're going to locate these little knobs in the bottom of your printer. They're all relatively the same. And you can see how it brings the nozzle closer or farther away from the print bed. Then you're going to take a sheet of paper, and I know it sounds really low tech, but you're going to take a sheet of paper, put it underneath the nozzle, between the nozzle and the bed. It is better to have the bed heated, so it's the temperature it's going to be, because remember, things expand when they're heated. And you're going to just move the nozzle back, or the dial back and forth in the bottom of the bed until it's just a little tight between the nozzle and the paper and the bed. This way, that tightness will make sure that the filament will adhere to the bed, that it's touching. If it's too far away, it won't touch, it'll slip around. If it's too close, you'll scratch the bed, or you'll just plug the nozzle up and it'll under extrude. It will be a mess. And you're going to do that for all four corners. Now again, turning off the stepper motors will allow you to move your bed back and forth. Now, some printers make this easy. Some printers make this process of leveling a little difficult. The Anycubic, the knob for the back is a little odd in where it's placed. But again, in your printer, it could be totally different. My CR10 is totally different, but you do the same thing. You put it in between the bed and the nozzle. You adjust it so that it's just scraping, so you're feeling a little tension, and you're done. And then once you're all set, you can go ahead and send it back home, and you can get printing with it. So it's really, really important. The first thing to do is to level that bed out, because if you don't, again, if it's too far away, it isn't going to stick. Now, this is a different printer. It's a CR10. But if your print head is too far away, you are not going to get this nice, even bead that is adhering to your print bed. So remember, first things first, level the bed and level it between each print. Super important. So let's take a look at bed adhesion. Now, we looked at some different types in the slides, but this is my setup on my CR10. I use a piece of glass, which I've sanded Then I spray it with Aquanet Extra Hold. You can get it at any department store. And I don't actually ever wash it off or scrape it. I just give it a light sanding and spray it again when it's warm. I let it dry. And in this way, you're going to get really great bed adhesion. I never have a problem with this on my CR10 or my other 3D printers that I use glass on. You're going to get that consistent line every time. Sometimes maybe not. You never know. It's not an exact science, but it usually will stick just fine. Now remember though, there are settings in Simplify 3D or your slicer that can also help with adhesion. But of course, the most important thing to do if you want great bed adhesion is this: level. Watch the leveling video, level your bed. If it is off a bit on one area, one corner, it's not going to stick. And then you're going to get bang, this nice little adhesion every time. It's going to stick and you're not going to have a problem. Okay, in this video, we're going to take a look at how to change the filament when it's almost out and you're in a print. So here we go. This filament is almost done. It's a little bit left. It's feeding a little bit in, a little at a time. You can see it's going through. Now, don't panic when this happens. Of course, you need to be home and you need to know what's happening. So what you can do is just have your filament ready and feed that through the tube. You might not have a tube. You might just have an opening. And you're going to squeeze to release the tension. This will help it go through the gears so that it can be fed through into the Bowden tube. So you might have to play around with this because, again, this happens very slowly. If you have retraction set up, it'll be popping in and out, but eventually you can see it'll start being taken up by the knob and the gear, and it'd be fed through the Bowden tube. You might have to, again, tweak it a little bit because it was maybe stuck, but keep at it, look down on it, make sure it's going through the opening and through the tube. Now, let's say you're lucky enough to have a newer printer, or not a newer printer, but just one that has one of these, and this is a filament sensor. This is an Anycubic i3 Omega. You feed it through there, the sensor, and then up through the drive gear. And what it's going to do is, once it passes through the last bit of it passes through that sensor, it will say, whoa, there's no more filament, and it'll turn off. And that's fantastic because then you haven't lost your print. So if that means something to you, if you're going to be doing a lot of printing when you're not at home, then you're definitely going to want to get something that has a filament sensor so you'll never have to switch filament in an emergency. In this video, I'm going to show you how to remove a print from your print bed. So as you can see here, we do have some supports that are, on the print, but we also, of course, have supports going from the print bed to the print. Now, how do we scrape this off? You could just try to pull this off, but I would always recommend using a knife like this. And most printers will actually come with one. And you want to gently sort of push it under there and just scrape away, keeping your hands away from the blade. I cannot tell you how many times I've seen people post photographs of some severe cuts they've gotten on their hand from trying to scrape that blade too hard and nicking their hand. So keep your hand away from the blade and just pull that thing off. Like we talked about in some of the previous video, you don't have to use a knife like this for some print beds. Some print beds will just pop right off, like the Anycubic Ultra Base and some of those twist ones. But for a lot of ones that use just a standard piece of glass or a mirror, you're going to need a scraper. Just remember, be careful and watch your hands. Okay, in this video, we're going to look at sanding your prints. Now, you don't have to, but it really will give you a smooth finish because remember, you have all these layer lines in how the plastic is laid down on the bed. So what I'll do is I will start with an 80 grit, which is very coarse, very aggressive, and you want to go fairly hard with this, but not too hard. You don't want to damage your print. Then I'll go to a 120 or maybe a 180. These are getting finer as we go up. Then either a 220 or a 320. Again, we're smoothing these lines. And then I finish up with a 400. Now, if it's for a helmet or something I want really glossy, what I'll do is a wet sand totally at the end after I have primed it with like a 2000 or 3000. Now, these foam sanders are really handy. One thing I like to do is wrap pieces of sandpaper around them so that they are easier to handle. And if it's a large area, what I'll also use is an orbital sander, but you want to be really careful because you can totally melt your prints. And remember, we're sanding plastic. Always wear a respirator. So yeah, this is extremely exciting. Here we go. We're going to just start sanding with an 80, and you can really see the lines now as the dust gets sort of trapped in those little areas. And you can see it better close up here. And you're just going to literally sand, sand, sand until you just don't want to do it anymore. Now, if you get these little cracks and crevices, little files are very helpful. There'll be links in the resources to some of this stuff so that you can get in there and really clean your print up. Because, you know, when you're finishing something and you're sanding it, yes, it is tedious, but if you're going to do it, get in there and make sure you have really cleaned it up as well as possible. Now, we did the 80, we're going to go to the 120. I'm not going to go through all of these because it would take forever, but you can see the lines are starting to go away even more now because we're going up the sandpaper. We've already taken the hard lines out and we're just smoothing it out more and more. Now, this is sort of jumping ahead in some of the videos, but this is after it has been primed. I am now going to wet sand this, and this 3000 grit sandpaper is like paper. I mean, it's almost impossible to feel any grit to it. And this will make this surface like glass. As long as you've already done your sort of prep work, it's going to work out really well. If you look at the Red Hood helmet, wet sanded that forever, and it looks really sharp. The one thing you want to do after you wet sand, though, is wash the print in soap and water to get that film off, and just let it air dry before you do your final coat. So that's it. That's sanding. It's extremely boring, but if you really want to get a sharp and nice glossy print without all those print lines, it's the only way to go. Okay, in this video, we're going to look at sanding your prints. Now, you don't have to, but it really will give you a smooth finish because remember, you have all these layer lines in how the plastic is laid down on the bed. So what I'll do is I will start with an 80 grit, which is very coarse, very aggressive, and you want to go fairly hard with this, but not too hard. You don't want to damage your print. Then I'll go to a 120 or maybe a 180. These are getting finer as we go up. Then either a 220 or a 320. Again, we're smoothing these lines. And then I finish up with a 400. Now, if it's for a helmet or something I want really glossy, what I'll do is a wet sand totally at the end after I have primed it with like a 2000 or 3000. Now, these foam sanders are really handy. One thing I like to do is wrap pieces of sandpaper around them so that they are easier to handle. And if it's a large area, what I'll also use is an orbital sander, but you want to be really careful because you can totally melt your prints. And remember, we're sanding plastic. Always wear a respirator. So yeah, this is extremely exciting. Here we go. We're going to just start sanding with an 80, and you can really see the lines now as the dust gets sort of trapped in those little areas. And you can see it better close up here. And you're just going to literally sand, sand, sand until you just don't want to do it anymore. Now, if you get these little cracks and crevices, little files are very helpful. There'll be links in the resources to some of this stuff so that you can get in there and really clean your print up. Because, you know, when you're finishing something and you're sanding it, yes, it is tedious, but if you're going to do it, get in there and make sure you have really cleaned it up as well as possible. Now, we did the 80, we're going to go to the 120. I'm not going to go through all of these because it would take forever, but you can see the lines are starting to go away even more now because we're going up the sandpaper. We've already taken the hard lines out and we're just smoothing it out more and more. Now, this is sort of jumping ahead in some of the videos, but this is after it has been primed. I am now going to wet sand this, and this 3000 grit sandpaper is like paper. I mean, it's almost impossible to feel any grit to it. And this will make this surface like glass. As long as you've already done your sort of prep work, it's going to work out really well. If you look at the Red Hood helmet, wet sanded that forever, and it looks really sharp. The one thing you want to do after you wet sand, though, is wash the print in soap and water to get that film off, and just let it air dry before you do your final coat. So that's it. That's sanding. It's extremely boring, but if you really want to get a sharp and nice glossy print without all those print lines, it's the only way to go. Okay, in this video, we're going to take a look at how you can fill some cracks and lines in your print. Even though you use a filler primer, these types of lines may still occur. You can only sand so much before you might even damage the plastic. So you can see some are small, like these are almost, non-existent, but they're there. You would see them. And others, however, can be a pretty big crack. You can see right there. And those are just print layer lines, and there's some other sort of minor ones. So what do? We could keep spraying this and spraying this and spraying this forever, but at this point we really need to use primer or different types of fillers. So first I usually start with a glazing primer, and sometimes this is all you need. I wear gloves and a respirator. And for here, I'm using a piece of foam. Now, this stuff is not meant for really huge gaps or, big voids. So if it's a really big crack, you probably don't want to use this, because this is just for glazing. This is just a light covering you want to use. And you're just going to go around all the places where you find these sort of layer lines. Now, I kind of went overboard here a little bit because I really wanted this faceplate to be super flat and shiny, because it's like one of the main things you look at, right, when you're looking at the person or the Ant-Man thing. So I went over this a lot, as you can see, way a lot. And now, of course, what we're gonna have to do, you probably guessed it, is sand the heck out of this thing. So we will also be sanding this to get all nice and smooth. Now, for the bigger cracks, you use Bondo. This is just a generic Bondo, and you use the main part of the Bondo, and then you use the accelerator, which is the blue stuff. And here I'm using just a spatula type thing that you can buy. And I could have probably just used the glazer with this glazing compound, but I decided, for the video to go ahead and show using Bondo. And again, it's the same type of a process. I try to put it on fairly thin, but I am kind of new to Bondo, I have to admit, and sometimes I can get a little messy with it. The key thing you want to remember with Bondo is a couple things. One, it smells horribly. So either make sure you do it in a well-ventilated area, and or outside. Don't mix up a lot, because the accelerator will harden it fast. So mix up little batches. Work slow and just cover your entire print. Try not to go back over it multiple times. Let it sit, smooth it out, and then you will sand it. And sanding it is pretty much the same as we looked at before, both of those things. You want to start with maybe a higher grit, something along the lines of like a 180 or 220, and then move your way up into wet sanding like we did in the sanding video. So that's it. That is filling voids and cracks. You can get both of those products on Amazon or over at any automotive store. Okay, in this video, we're going to take a look at how you can fill some cracks and lines in your print. Even though you use a filler primer, these types of lines may still occur. You can only sand so much before you might even damage the plastic. So you can see some are small, like these are almost, non-existent, but they're there. You would see them. And others, however, can be a pretty big crack. You can see right there. And those are just print layer lines, and there's some other sort of minor ones. So what do? We could keep spraying this and spraying this and spraying this forever, but at this point we really need to use primer or different types of fillers. So first I usually start with a glazing primer, and sometimes this is all you need. I wear gloves and a respirator. And for here, I'm using a piece of foam. Now, this stuff is not meant for really huge gaps or, big voids. So if it's a really big crack, you probably don't want to use this, because this is just for glazing. This is just a light covering you want to use. And you're just going to go around all the places where you find these sort of layer lines. Now, I kind of went overboard here a little bit because I really wanted this faceplate to be super flat and shiny, because it's like one of the main things you look at, right, when you're looking at the person or the Ant-Man thing. So I went over this a lot, as you can see, way a lot. And now, of course, what we're gonna have to do, you probably guessed it, is sand the heck out of this thing. So we will also be sanding this to get all nice and smooth. Now, for the bigger cracks, you use Bondo. This is just a generic Bondo, and you use the main part of the Bondo, and then you use the accelerator, which is the blue stuff. And here I'm using just a spatula type thing that you can buy. And I could have probably just used the glazer with this glazing compound, but I decided, for the video to go ahead and show using Bondo. And again, it's the same type of a process. I try to put it on fairly thin, but I am kind of new to Bondo, I have to admit, and sometimes I can get a little messy with it. The key thing you want to remember with Bondo is a couple things. One, it smells horribly. So either make sure you do it in a well-ventilated area, and or outside. Don't mix up a lot because the accelerator will harden it fast. So mix up little batches, work slow, and just cover your entire print. Try not to go back over it multiple times. Let it sit, smooth it out, and then you will sand it. And sanding it is pretty much the same as we looked at before, both of those things. You want to start with maybe a higher grit, something along the lines of like a 180 or 220, and then move your way up into wet sanding like we did in the sanding video. So that's it. That is filling voids and cracks. You can get both of those products on Amazon or over at any automotive store. In this video, we're going to take a look at how to print your props. Now, the first thing you're going to want to do, of course, is sand it and everything. Look at those other videos. But then we're going to want to maybe tape some areas off. Let's say we don't want certain areas covered. You can tape them up. I usually use blue painter's tape and some plastic bags if necessary. I'm also looking at reference material, and I'm spray painting outside for the most part when I can. I don't spray in the house anymore because it smells horribly. Now, this is the last time I sprayed in the house. Now, as you can see, when you're using rattle cans like this, you don't want to get super close because you're going to get runs. Runs are the worst thing that can happen because then you got to let it dry and go back, sand it a little bit, and then go back over it. As you can see, I'm a good 10, 12 inches away from this print, and that is giving it this nice even coat. And you want to keep moving over the print, never pointing it directly at the print when you're starting, but off to the side, and then do passes over it. And don't stop once you're moving because then you could get runs, and runs are terrible. And if you do it right, this is the kind of look you can get, this nice smooth shine. Now, sometimes you also going to want to, after you do spray painting, you're going to want to paint in some details possibly. And this is a pistol from Fortnite. It's a video game. And I'm just using cheap acrylics. Again, you can look in the resources for which ones I use. And you're going to use cheap brushes, and you can just paint in the little details. So you're not just spray painting. You can also be doing brushwork. And now here's a statue where, again, I'm using tape, blue painter's tape, to mask areas off, and then I'm going in with a X-Acto knife, and I'm trimming away into the areas where then I can just remove the tape, and I get a nice clean line. You might need to push it down a little bit, and you can get nice clean lines that look like this. The key thing when you're masking, though, wait until it dries. Give it 24 hours before taping. And again, sometimes we're not using masking tape. Sometimes we're not using any type of rattle cans. This is something that I did spray paint, but that I then just went over again with a simple brush to add all the detailed colors that I need. And I'm not using anything special here. These are basic paints. That's the name brand, and just cheap brushes that I got from Amazon or Walmart. And now, yes, this is just the base coat. In the next few segments, we're going to look at how to add detail with your brushes, because the way we can add detail when using rattle cans, of course, is to mask. But how do we add that detail with brushes? Now, again, I just use these simple basics paints, and I'm going to show you a little bit of painting this Thanos statue. Now, I keep reference material with me, and I just print the stuff out from the web. And this is actually a great site. It's Hot Toys website, and they have some very, very accurate models. They're incredible, but you can get some really good color schemes from this. And then what you can do is get your cheap brushes out and start painting. I'll use a paper plate. Sometimes I'll use a piece of glass, but I'll always start with just adding the base coat. And sometimes I use a little card to put it on, or whatever, whatever you have. And you're just going to put your base coat down. And this doesn't look all that spectacular. Yes, it does fill up the space, but when we start adding some details using darker and lighter colors, that's where things will really shine. Okay, now here we have Thanos, and it's the base coat. It's that purplish base coat. And as you can see, I'm just mixing, and it's a mirror or a piece of glass I've got down there. I'm mixing my base coats with whites, and I'm going to start adding highlights. Now, how you want to work this type of thing is where an area is raised, or it's closer to you, or it's closer to the light source, that area is going to be lighter. So the ridges of his chin are going to be lighter than the recessed crevices of it. Again, same thing with his lip. The tip of his lip is going to be brighter. And you can already see that this is creating more of a sense of depth in this print. And then I'll just sort of add a little bit more white here and there to bump it up. Now, if you're not sure, I do some painting. If you're not sure how this would look, get a camera and take a photograph of yourself with a light shining on you the way you see it there, or look at some different painting books, and it'll give you a sense of what to do. So here I am just adding some, again, tinted color to the bridge of the nose because it's closer to you. It's going to look a little bit brighter, and it's going to stand out more. I'm going to get the little sides of the nostrils, and you can already see that just doing this, and this brush is probably way too big to be painting this nose, but you get a sense of what I'm going for here. And you're just going to build up the highlights and then possibly add some shadows. The purple is dark enough for me, so I decided not to add a lot of shadows into this because I thought the purple was dark enough. You could go ahead and add some darker purple into the crevices of his chin to make it stand out even more. But as you can see, I don't have a lot of paint on this brush, and I'm just tapping it in the highlighted areas, the higher areas of his flesh, so that it looks raised and it gives it more dimension. And have fun with this, building up the detail like this, because if you make a mistake, you can always go back, let it dry, and paint it purple again. Your base color, or whatever your base color is, like that. I thought that was a little too purpley, so I went ahead and I wiped some of it off. I'll wait till it dries, and I'll just go over it. I'm blending, and that's what you're doing. You're blending color upon color to get that three-dimensional effect and that sense of depth. Okay, so now I'm going to speed up the video a little bit so you can see different parts in this process because it took quite a while. And here we are pretty much towards the end, painting the eyes in. Yes, I did do a horrible job on that one eye, but I went back and fixed it after it dried. And you can see what the highlights do. I did add a little bit of darkness into the shadows, but it gives it that dimension, and it's really fun building things up like that. Now, the other thing you can use is an airbrush, and this is just a cheap airbrush kit that I bought on Amazon. And this allows you to really get some fine gradations and control. So in this Star-Lord build, I've put down some red metallic. It also lets you buy some really specialized, like translucent and metallic-y colors, and it gives you tremendous control. So as you can see, it's just a fine mist coming out, and I can control where that goes and to how much I want to go on. It's not super easy. It's something that I learn about each time I do it, each material, but it can give you some tremendous control. And again, these kits are not very cheap. If you just go to the resources, you can get some ideas on what kits you could try. In this video, we're going to take a look at how to print your props. Now, the first thing you're going to want to do, of course, is sand it and everything. Look at those other videos. But then we're going to want to maybe tape some areas off. Let's say we don't want certain areas covered. You can tape them up. I usually use blue painter's tape and some plastic bags if necessary. I'm also looking at reference material, and I'm spray painting outside for the most part when I can. I don't spray in the house anymore because it smells horribly. Now, this is the last time I sprayed in the house. Now, as you can see, when you're using rattle cans like this, you don't want to get super close because you're going to get runs. Runs are the worst thing that can happen because then you got to let it dry and go back, sand it a little bit, and then go back over it. As you can see, I'm a good 10, 12 inches away from this print, and that is giving it this nice even coat. And you want to keep moving over the print, never pointing it directly at the print when you're starting, but off to the side, and then do passes over it. And don't stop once you're moving, because then you could get runs, and runs are terrible. And if you do it right, this is the kind of look you can get, this nice smooth shine. Now, sometimes you're also going to want to, after you do spray painting, you're going to want to paint in some details possibly. And this is a pistol from Fortnite. It's a video game. And I'm just using cheap acrylics. Again, you can look in the resources for which ones I use. And you're going to use cheap brushes, and you can just paint in the little details. So you're not just spray painting. You can also be doing brushwork. And now here's a statue where, again, I'm using tape, blue painter's tape, to mask areas off, and then I'm going in with a X-Acto knife, and I'm trimming away into the areas where then I can just remove the tape and I get a nice clean line. You might need to push it down a little bit, and you can get nice clean lines that look like this. The key thing when you're masking, though, wait until it dries. Give it 24 hours before taping. And again, sometimes we're not using masking tape. Sometimes we're not using any type of rattle cans. This is something that I did spray paint, but that I then just went over again with a simple brush to add all the detailed colors that I need. And I'm not using anything special here. These are basic paints. That's the name brand, and just cheap brushes that I got from Amazon or Walmart. And now, yes, this is just the base coat. In the next few segments, we're going to look at how to add detail with your brushes, because the way we can add detail when using rattle cans, of course, is to mask. But how do we add that detail with brushes? Now, again, I just use these simple basics paints, and I'm going to show you a little bit of painting this Thanos statue. Now, I keep reference material with me, and I just print the stuff out from the web. And this is actually a great site. It's Hot Toys website, and they have some very, very accurate models. They're incredible, but you can get some really good color schemes from this. And then what you can do is get your cheap brushes out and start painting. I'll use a paper plate. Sometimes I'll use a piece of glass, but I'll always start with just adding the base coat. And sometimes I use a little card to put it on, or whatever, whatever you have. And you're just going to put your base coat down. And this doesn't look all that spectacular. Yes, it does fill up the space, but when we start adding some details using darker and lighter colors, that's where things will really shine. Okay, now here we have Thanos, and it's the base coat. It's that purplish base coat. And as you can see, I'm just mixing, and it's a mirror or a piece of glass I've got down there. I'm mixing my base coats with whites, and I'm going to start adding highlights. Now, how you want to work this type of thing is where an area is raised, or it's closer to you, or it's closer to the light source, that area is going to be lighter. So the ridges of his chin are going to be lighter than the recessed crevices of it. Again, same thing with his lip. The tip of his lip is going to be brighter. And you can already see that this is creating more of a sense of depth in this print. And then I'll just sort of add a little bit more white here and there to bump it up. Now, if you're not sure, I do some painting. If you're not sure how this would look, get a camera and take a photograph of yourself with a light shining on you the way you see it there, or look at some different painting books, and it'll give you a sense of what to do. So here I am just adding some, again, tinted color to the bridge of the nose because it's closer to you. It's going to look a little bit brighter, and it's going to stand out more. I'm going to get the little sides of the nostrils, and you can already see that just doing this, and this brush is probably way too big to be painting this nose, but you get a sense of what I'm going for here. And you're just going to build up the highlights and then possibly add some shadows. The purple is dark enough for me, so I decided not to add a lot of shadows into this because I thought the purple was dark enough. You could go ahead and add some darker purple into the crevices of his chin to make it stand out even more. But as you can see, I don't have a lot of paint on this brush, and I'm just tapping it in the highlighted areas, the higher areas of his flesh, so that it looks raised and it gives it more dimension. And have fun with this, building up the detail like this, because if you make a mistake, you can always go back, let it dry, and paint it purple again. Your base color, or whatever your base color is, like there. I thought that was a little too purpley, so I went ahead and I wiped some of it off. I'll wait till it dries, and I'll just go over it. I'm blending, and that's what you're doing. You're blending color upon color to get that three-dimensional effect and that sense of depth. Okay, so I'm going to speed up the video a little bit so you can see different parts in this process because it took quite a while. And here we are a little, pretty much towards the end, painting the eyes in. Yes, I did do a horrible job on that one eye, but I went back and fixed it after it dried. And you can see what the highlights do. I did add a little bit darkness into the shadows, but it gives it that dimension, and it's really fun building things up like that. Now, the other thing you can use is an airbrush, and this is just a cheap airbrush kit that I bought on Amazon, and this allows you to really get some fine gradations and control. So in this Star-Lord build, I've put down some red metallic. It also lets you buy some really specialized, like translucent and metallic-y colors, and it gives you tremendous control. So as you can see, it's just a fine mist coming out, and I can control where that goes and to how much I want to go on. It's not super easy. It's something that I learn about each time I do it, each material, but it can give you some tremendous control. And again, these kits are not very cheap. If you just go to the resources, you can get some ideas on what kits you could try. Okay, in this video, we're going to take a look at using polymers to actually smooth and finish your prints. So like we talked about, you can use stuff like XTC, or you can use cheaper things like this amazing, I think it's called like amazing acrylic or something like that. Either one will work. I, of course, always wear gloves because this stuff is crazy sticky, and you'll use a cheap little brush, whichever kind you want, and a cup that you can measure it in, and something to stir it up. So the first thing you want to do, of course, is get your gloves on, because this stuff can be a real mess. So I just went ahead and got part A. You put 2 parts of part A, and all of them are different. So I'm putting it in the cup, measuring it out. So there's going to be my 2 parts, and then I need to do 1 part of B. This was for a little bit more runny. It kind of came out quickly, and I'm putting in 1 part of B. There's little tick marks on that cup to know where I got to put it at. And of course, you have to stir this thing up, because if you don't, it will not work. So give it a really good stirring so that each piece mixes into one solution. Once everything is stirred up, just dip your chip brush in, get a decent amount on there, and just start spreading it on your piece. Now you might see that I am working on a piece of glass. When this stuff dries, it is very sticky, obviously. And if you put it on newspaper or paper or something, it will pull it right up. So glass seems to do a good job. And you can see what this stuff does is it doesn't melt, it doesn't sand. It covers the piece with a thin or thick layer of plastic, of a liquid polymer, that when it dries, it will be hard as plastic. Now, you see some brush lines, but this stuff will even out. You can see here how sort of glass sharp this is. Here's the problem with this stuff. If you've got a very fine and delicate piece, like say you're doing a miniature or you're doing something just with a lot of detail, this stuff will gum that up because it fills spaces. And that space being filled, of course, will make you lose detail. So again, here, look how sharp this is. Smooth, ready to go, a light sanding, and this will be totally ready to, totally ready to go with almost no laborious sanding. But again, you lose detail. So there you go. That's XTC and or any other polymer. Makes nice smooth prints, but you will lose detail. Okay, in this video, we're going to take a look at using polymers to actually smooth and finish your prints. So like we talked about, you can use stuff like XTC, or you can use cheaper things like this amazing, I think it's called like amazing acrylic or something like that. Either one will work. I, of course, always wear gloves because this stuff is crazy sticky, and you'll use a cheap little brush, whichever kind you want, and a cup that you can measure it in, and something to stir it up. So the first thing you want to do, of course, is get your gloves on, because this stuff can be a real mess. So I just went ahead and got part A. You put 2 parts of part A. Again, all of them are different. So I'm putting it in the cup, measuring it out. So there's going to be my 2 parts, and then I need to do 1 part of B. This was for a little bit more runny. It kind of came out quickly. And I'm putting in 1 part of B. There's little tick marks on that cup to know where I got to put it at. And of course, you have to stir this thing up, because if you don't, it will not work. So give it a really good stirring so that each piece mixes into one solution. Once everything is stirred up, just dip your chip brush in, get a decent amount on there, and just start spreading it on your piece. Now you might see that I am working on a piece of glass. When this stuff dries, it is very sticky, obviously. And if you put it on newspaper or paper or something, it will pull it right up. So glass seems to do a good job. And you can see what this stuff does is it doesn't melt, it doesn't sand. It covers the piece with a thin or thick layer of plastic, of a liquid polymer, that when it dries, it will be hard as plastic. Now you see some brush lines, but this stuff will even out. You can see here how sort of glass sharp this is. Here's the problem with this stuff. If you've got a very fine and delicate piece, like say you're doing a miniature or you're doing something just with a lot of detail, this stuff will gum that up because it fills spaces. And that space being filled, of course, will make you lose detail. So again, here, look how sharp this is. Smooth, ready to go, a light sanding, and this will be totally ready to, totally ready to go with almost no laborious sanding. But again, you lose detail. So there you go. That's XTC and or any other polymer. Makes nice smooth prints, but you will lose detail. Okay, in this video, we're going to learn how to weather our prints. Now, this is one of my favorite parts. Now, I usually use an old paper plate or something, a little bit of water, and like we looked at in the slideshow, some cheap acrylic paints, some browns, some burnt umbers, some blacks. And what you're going to want to do is you're going to want to brush this stuff on liberally, depending how worn out you want it to look. And then I usually will dab it with a paper towel. Now you want to be careful. Obviously don't take everything off or you've just defeated the purpose. But you also want to concentrate on where would this, suit or object get dirty. So, in the cracks and crevices between his elbow and his arm there, in his chest place, wherever there's a crack or a crevice, you definitely want to add more weathering to that, because that's the thing that took the most weathering. And now for most of this, I want it all to look fairly dirty. So I'm really sort of brushing it everywhere where I think it would be a little bit shaded, and I'm also, or dirty. And I'm also using a little bit of it for shading. So like under his nose, I'm putting some shadow. And in this way, I don't have to get in there with paint. And now again, I'm just dabbing it off with a paper towel. Now, sometimes I don't use a paintbrush. I will ball up a paper towel because it has that sort of distressed look to it, or it's random. Well, maybe a little more random I can do with the brush. I dip it in some fairly dry paint and then just dab it all over the piece. And in this way, by not, trying to be very uniform, just moving my hand around quickly, again, where I think it would take some of the dirt, I can make things look like smudges or dirt patterns just with a paper towel. And again, I'm using a fairly dry paint mixture over there. You can see there's hardly anything on the actual paper towel at all. And I love this part because it really starts making the object look lived in. Now, here's a helmet, and this is a Fortnite helmet. And it's funny because we make it look all pretty and do our best. And then there we go. Since this is so much bigger, I use a little chip brush, very cheap. You can get them wherever. And I've got a mixture of black and brown. And this helmet's a fairly worn helmet, so I'm brushing pretty much everything. But what, of course, I'm going to do is I'm going to make sure that wherever there's a little sort of crack or crevice you can see around by the skull, by the spikes, those are, areas that dirt and grime would sort of cake into. So I'm making sure to not wipe a lot away from that, and I'm wiping some off on the other thing, but it's still making it look dirty and grimy and kind of not so brand new, because this is a helmet that the person's been wearing in a game, fighting and whatnot. And I'm looking at this now, and I probably took way too much off the first round, but you can, of course, keep adding more and more, but it did brown it up and make it look a little dirty. And as you can see in the crack there in that seam, I really left a lot of paint because, again, that is a crack, and paint would get in there, or not paint, but dirt and grime would get in there and it would stay there. So I might put it on really thick in those areas and wipe away less so that I will make sure that it looks like it's been worn. And here I am again using a paper towel with some fairly dry paint because we don't want it to be running around. And I'm just making those sort of little dabby marks, where that's a technical term, dabby marks, so that it looks natural. And again, I'm hitting around those spikes because, again, dirt would collect there and it's going to make it look more realistically worn. Now, this takes a little bit of time, and you really can't screw it up totally. I mean, you can wash some of this paint off. But I love doing this because it really then makes this prop look real, like it's been worn, it's been used, and it's my favorite because it's just, you get in there and, you're trying to find where it would be most dirty and just have fun with it. It's the least precise part of the whole process. At the same time, you want to sort of go through it quickly and make it dirty and not let things dry too much. I might be painting way too much on here before I dab it off, but then I'm just going to go through and dab it off and, make it look not completely painted. And then I'll just go through again with the paper towel and start dabbing away to clear all this paint. I'll let it sit a little bit. Again, don't wipe everything off, because if you wipe everything off, what was the purpose? But I tend to do that. Again, I guess if you wipe too much off, it's no big deal. You just go ahead and reapply. And this, again, it's something that you can't ruin your prop. You can always clean it, wash it off. I guess technically you could ruin it. You could let it dry and it would just stay that dark, dark paint, and then you have to paint over it. Here's another Fortnite weapon. As you can see, I'm using another big chip brush because this thing is huge. And you can see I'm putting dirt and grime down where it would more than likely be. This is a part of the handle that you would hold on to, the pump part of it. And I just spilled a cup of coffee. That is very funny. Let's go ahead and cut that. Okay, and I'm back. Now remember, don't leave your coffee cups when you got a huge prop that you're working on. And again, I'm brushing on where your hand is, where it's going to wear and get all the grime and dirt. And of course, it's grooves, your hand's there. I'm going to just brush it on. And then again, I'll take a paper towel and dab it off. So have fun with this part. It's really neat. But the main thing is think about where dirt would end up. And just use some cheap acrylics, browns, blacks, some oranges maybe, and some cheap brushes, and as they say, go ahead and brown it up. Okay, in this video we're going to learn how to weather our prints. Now this is one of my favorite parts. Now I usually use an old paper plate or something, a little bit of water, and like we looked at in the slideshow, some cheap acrylic paints, some browns, some burnt umbers, some blacks. And what you're going to want to do is you're going to want to brush this stuff on liberally, depending how worn out you want it to look. And then I usually will dab it with a paper towel. Now you want to be careful. Obviously don't take everything off or you've just defeated the purpose. But you also want to concentrate on where would this, suit or object get dirty. So, in the cracks and crevices between his elbow and his arm there, in his chest place, wherever there's a crack or a crevice, you definitely want to add more weathering to that, because that's the thing that took the most weathering. And now for most of this, I want it all to look fairly dirty, so I'm really sort of brushing it everywhere where I think it would be a little bit shaded, and I'm also or dirty, and I'm also using a little bit of it for shading. So like under his nose, I'm putting some shadow, and in this way, I don't have to get in there with paint. And now again, I'm just dabbing it off with a paper towel. Now sometimes I don't use a paintbrush. I will ball up a paper towel because it has that sort of distressed look to it, or it's random, well, maybe a little more random I can do with the brush. I dip it in some fairly dry paint and then just dab it all over the piece. And in this way, by not, sort of trying to be very uniform, just moving my hand around quickly, again, where I think it would take some of the dirt, I can make things look like smudges or dirt patterns just with a paper towel. And again, I'm using a fairly dry paint mixture over there. You can see there's hardly anything on the actual paper towel at all. And I love this part because it really starts making the object look lived in. Now here's a helmet, and this is a Fortnite helmet, and it's funny because we make it look all pretty and do our best, and then there we go. Since this is so much bigger, I use a little chip brush, very cheap, you can get them wherever, and I've got a mixture of black and brown, and this helmet's a fairly worn helmet, so I'm brushing pretty much everything. But what of course I'm going to do is I'm going to make sure that wherever there's a little sort of crack or crevice you can see around by the skull, by the spikes, those are areas that dirt and grime would sort of cake into. So I'm making sure to not wipe a lot away from that, and I'm wiping some off on the other thing, but it's still making it look dirty and grimy and kind of not so brand new, because this is a helmet that the person's been wearing in a game, fighting and whatnot. And I'm looking at this now, and I probably took way too much off the first round, but you can of course keep adding more and more, but it did brown it up and make it look a little dirty. And as you can see in the crack there in that seam, I really left a lot of paint because again, that is a crack, and paint would get in there, or not paint, but dirt and grime would get in there and it would stay there. So I might put it on really thick in those areas and wipe away less so that I will make sure that it looks like it's been worn. And here I am again using a paper towel with some fairly dry paint because we don't want it to be running around. And I'm just making those sort of little dabby marks, where that's a technical term, dabby marks, so that it looks natural. And again, I'm hitting around those spikes because again, dirt would collect there and it's going to make it look more realistically worn. Now this takes a little bit of time, and you really can't screw it up totally. I mean, you can wash some of this paint off, but I love doing this because it really then makes this prop look real, like it's been worn, it's been used, and it's my favorite because it's just, you get in there and, you're trying to find where it would be most dirty and just have fun with it. It's the least precise part of the whole process. At the same time, you want to sort of go through it quickly and make it dirty and not let things dry too much. I might be painting way too much on here before I dab it off, but then I'm just going to go through and dab it off and, make it look not completely painted. And then I'll just go through again with the paper towel and start dabbing away to clear all this paint. I'll let it sit a little bit. Again, don't wipe everything off, because if you wipe everything off, what was the purpose? But I tend to do that. Again, I guess if you wipe too much off, it's no big deal. You just go ahead and reapply. And this, again, it's something that you can't ruin your prop. You can always clean it, wash it off. I guess technically you could ruin it. You could let it dry and it would just stay that dark paint, and then you have to paint over it. Here's another Fortnite weapon. As you can see, I'm using another big chip brush because this thing is huge. And you can see I'm putting dirt and grime down where it would more than likely be. This is a part of the handle that you would hold on to, the pump part of it. And I just spilled a cup of coffee. That is very funny. Let's go ahead and cut that. Okay, and I'm back. Now remember, don't leave your coffee cups when you got a huge prop that you're working on. And again, I'm brushing on where your hand is, where it's going to wear and get all the grime and dirt. And of course, it's grooves, your hand's there. I'm going to just brush it on. And then again, I'll take a paper towel and dab it off. So have fun with this part. It's really neat. But the main thing is think about where dirt would end up. And just use some cheap acrylics, browns, blacks, some oranges maybe, and some cheap brushes, And as they say, go ahead and brown it up. So this video marks one of the biggest builds I've ever done, and I got this file over at DO3D. As you can see, they've got amazing files, Infinity Gauntlets, full suits, guns. We're going to be focusing on one of my favorite characters, Batman, and we're actually going to be doing this Batman Justice League Tactical Batsuit. And as you can see, all the raised parts, that's what we're going to be printing. And you can look at the site, you've got all the head, and that should be interesting to split up. We've got the chest pieces. We've got all this stuff. As you can see, it looks awesome. I cannot wait to print this. Now, of course, these are not going to fit on the bed. I've got a CR10, and it's a big printer, but not this big. So what we're going to be doing is we're going to be using Mesh Mixer to actually split these files up so that they will print really well on that CR10. Okay, now some people can be a little intimidated with Mesh Mixer, so let's go ahead and look for the file we want to start with for the Batman Tactical Suit by DO3D. And this suit is awesome. I've been wanting to make this for a while, and I got these files over at DO3D. Go check them out. Amazing stuff. Now, as you can see, it's a little big. There's a lot of pieces, parts. We are not going to be able to print that in one shot. How nice would that be? So first, let's take a look at separating the shapes here, and we'll be able to see how many pieces this model is broken into. And sometimes it can take a little while because it's a big file. And then the object browser pops up and we can see there are a lot of shapes. And this is good because now we can split this up how we want. So every little rivet, every little thing is a shape. So you can see I turn the eye off and the back pieces go away. And the problem is they, of course, don't go in really serious order. So you kind of got to feel your way through until you get used to it. So I'm just going to go ahead and turn off everything other than the chest piece. And yes, they are grouped together once you start figuring out how they're sort of set up in the browser. And what you'll need to do is you need to turn off all the things that you don't want to export as one piece. So as you can see here, I'm turning off all the rivets, all the pieces, all the parts, and if you notice, sometimes I'll hit turn an eye off and a piece from the chest goes away. So I just put the eye back on, open it back up, and in this way, that piece doesn't go away. And you can see for a file this big, this takes a little bit to get used to where everything is set up. And we've almost got it now. Yes, there we go. Everything is gone except for the chest pieces. So now I need to split it so I just have one side, one pec. So I'm going to go through with the little eyes and shut them and make sure that everything is off that I want off, but not on that side. And sometimes you'll shut off an eye and you'll be like, wow, where did that piece come from? You might have to rotate the model to see where it came from. You'll get more and more used to it as you go. And there we go. I got that last rivet. So now here we've got just this one pec, and we can export just that and send it to our send it to an STL file, create an STL. So you have to select, so you can command or control whatever sort of computer you're on, the pieces. You have to select all of them. Then you go to File and you export, and you export it as an STL, and really work on your naming convention here. So I'm going to call this Batman Tactical. What should I call it? Pec 1 maybe? No, pec left, pec right, chest. There we go. I recorded this about 2 weeks ago and I forgot what I called it. So it's chest right. So there we go. And now it is exporting that as the right chest piece. And again, this can take a little bit of time. It all depends on how complex the drawing is. And as you can see, that's real time. It took not long. Now I'm shutting the eyes off on that side. And I'm going to turn around and turn the eyes back on for the other side. Now you can see I've got that back piece showing up. It's because I actually have that one selected all the way up top. It's not on because the eye's not on, but we can see it. So I've just got to go through here and find, again, all the little pieces, parts that make this up. Now, as I go through this thing more and more to isolate everything, I start to remember where everything is. and things go a lot faster. But this is what you need to do when you've got a big model. You've got to actually split it all up and make sure you can get it on your print bed. So there we go. We're almost there. And I'm going to find this last little rivet if it kills me. And hopefully it won't kill me, because then I won't be able to print this awesome Batman suit. I cannot wait to have this thing done. This is going to take forever. I've never printed a suit before, a complete suit, so I'm really super excited to do this, especially the painting and the weathering, where I'm going to add LEDs. I can't wait. All right, for some reason I'm not finding this last rivet. Where were those rivets again? Ah, there we go. So now again, I go ahead and Command or Control. I'm on a Mac, so I Command click all the things with the eyes on, and that selects them. If you don't do that, if you just have the one, it'll just do the one piece. So there we go. That's the last one to go. Now we just go ahead and export that, and now we'll have the other side. So now I just go ahead and click on that name, and then I change it. Now don't forget to change it to left or whatever, or you'll copy over your file. So this way I've got these things broken up file-wise, because there's going to be a lot of files, and I want to easily be able to figure out which is which. So now I've got the Batman chest left, Batman technical chest right, and then I can go through all the files. Now, here's the thing. We still have to break up pretty much everything else. Now, we're going to go with the miracle of modern video editing really quickly through it. And again, you can see I'm just turning things on and off, making sure I have the correct pieces that go with that, and then I am exporting them. Now, I thought I would try to do 2 at a time for the abs, because I'm pretty sure I can print that, and then the last 2 on the bottom. And if I have to split them up, I will. So here we are. We are now in Simplify 3D. It's what I use, and I'm choosing the Batman chest piece. And you can see that will fit just fine. I use a CR10, and you can see the coupon code down in the description. And go overhead and pick one of those up if you've been dying to get a printer. It is awesome. And if you purchase from that link, it helps the channel out. It can make me able to do more reviews, and just helps us out. So now I'm sort of centering this peck on here, and it's a weird shape. And sometimes half the art of printing is figuring out how to lay things out on your bed. And as you can see, there's high points, there's low points, and you really have to tweak your X, Y to really see how many points you can hit the bed with, and sort of fool around with it. And it can take a while. So I think that is pretty good. It's got some points that I'm a little concerned about, but the first print I make of this will probably be with like 0 infill, just to see how things go. I'm then going to generate some supports to see. That's a lot of support material. I don't know if there's any way around that. I definitely don't want to flip this, because if I flip it, there could be a problem. But let's go ahead and take a look and see what happens if we try some different configurations. Okay, so like I said, I just flipped it over actually, and here it is on the face. Now, not really happy with this one. I mean, it uses probably just about, maybe just as much, but here's the problem. If you're going to print something like this, what ends up happening is you could really scar the front with support material. It's a lot more sanding, and I don't really think it is the way to go, so we probably won't use this configuration. Like I said, it takes a little bit of time to figure this one out, and again, this one just is not going to do it. Okay, let's try one more, tipping this up. Not really happy with this. I don't have the best of luck with these really long supports. They tend to get a little wobbly, they tend to move, and then your print dies when it gets up top. Now, this not doing it for me. So what we're probably going to do is we're probably just going to go ahead and go back to this setup. Now, even this, I'm not sure about, because there's a lot of points in looking at it that it could fail. Those buckles make me a little bit nervous. So I have an idea on what I think I want to do with this so that I can print it a lot easier. Okay, now we're back in Mesh Mixer, and you can see all I did was import the peck piece that we cut up and brought over. And I'm going to try to see if we can make this a little bit smaller so that we can not have such large print time and have so much support material. So first thing I'm going to do is I'm going to go over and look at my object browser and then go to plane cut. And then you can see we got a little line here. If I move out, you can see I'm hitting those little tick marks. It's ticking it off in solid increments like 90 degrees, 95 degrees. So that's really handy. Always use those or you could get a wonky cut. So I'm going to come right in the sort of, not in the middle, but I'm going to split it right here. And then you choose keep both. You want to keep both and hit OK. Then we go back to the object browser and we say, separate shapes or separate shells. And there we go. We got a straight line going right down. And as you can see, if I click away, it's just like it was earlier when we had the full suit. I've split this. There's no loss of material. And now I'm going to be able to export this as a smaller pec piece. So just like before, we sort of isolate and find our pieces to see what is where. And we turn off what we don't want in the first piece of the STL we're going to export. Now, once we've figured that out and we get rid of those two little bolts there, or whatever they are, nuts, you can see we've got the main sort of file here. Now, again, we select both pieces. So you can see where the eyes there, I commanded selected. And we export this. And I'm going to call it a Batman Tactical Chest, just like I had before, right, part 1. So again, I know exactly this is the chest piece and it's part 1. Then, of course, we just go ahead and do the exact opposite. We turn on the other side to make sure that we export that. And you'd think I would know what it is by now, but I don't. So we turn that on. We go through and we select all the eye open ones, so those export. We go to File, Export. And I'm going to select this and then change this to 2. So it's now Technical Chest Right Half 2. Again, name things very, very, thoroughly. This way you never have to be like, oh, what file am I bringing in? What file am I not? For something like this, I'm going to then, once I have everything split up, I'm going to put a spreadsheet together. And I'm going to sort of record how much material is used. I can check off which things I've had done, which ones I've painted. Now you can look, we're back here to the Simplify 3D. I'm going to get rid of that. And I'm going to bring in that half that we just made. And you can see a lot different, a lot smaller. And we're going to go ahead and situate this on the bed a little differently and just see it'll print extremely fast. We can maybe even put 2 down. I think that's what I'll end up doing, putting 2 chess pieces down at the same time. And then this way we don't have to wait too long. And if we rotate this, I don't think I'm going to rotate it that way. I think I'm actually going to drop it down on its side like this. This way it's got a nice clean area on the bottom. And it isn't going to use too many supports, hardly if any. A little bit here and there. Again, I'm going to tweak it a little bit more. We might even be able to get rid of these. I'd like to try to have as few supports in the front end as possible. And again, always do this. Flip your pieces around. See, what uses the least amount of supports. What is the most stable on the bed. And in this way, it could always cut down on your print time. So let's go -90. And let's see what happens when we look at it this way. We're going to clear the supports. We're going to center the piece. We got to move some things out of the way. And you can see that one might not work too well because the piece has that little sort of arc to it. So you've got those, you've got that little space. So I think I'm going to go bring it back to 90 and drop it in and use that. Now, I think this will be the way I'm going to print it. I'm really actually happy with that. All right, and after some tweaking, this is what I ended up with. And let's see, let's go to prepare to print. It's calculating and taking a little while. There's a bunch of stuff it's got to figure out. What are we going to bring? 15 hours. That's a lot for that piece. I'm still going to do some tweaking with my speed and my everything. I think I'm at 0.1 layer height. So we're going to tweak it around and we're going to see what's going to happen. And now again, I'm just going to do the same thing with this piece that I did with the other piece. So I'm just going to bring this other half in, the bigger half, drop it down, and sort of, like I said, just work it around to see which way it lies best. Okay, I might tweak this some more, but this is along the lines I think where I'm going with it. There were too many supports that were like sort of raised and high supports. If anyone's watching this and has a better idea, obviously I totally want to hear that, so go ahead and leave some comments below. But this looks like where we're going to leave it, and we're looking at a lot of hours to print this. This is going to take quite a bit of time, this whole suit, but I can't wait. I am super excited. Dio 3D, amazing files. This is just going to be fantastic. All right, so I have a lot more work to do, chopping up these files and getting them ready for the printer, aligning them on the bed. Now again, I use a CR10. It is a workhorse. Everyone I'm sure has heard of it. If you're interested in picking one up, go to the description below and you can see a coupon code, and that'll get you some money off over at GearBest, which is pretty neat. Also, check me out over at Patreon, so just go to patreon.com/3dprintedprops, or again, go to the description to click on the link. And last but not least, I am jumping on the Buy Me a Coffee bandwagon. As you can see in my videos, if you've watched any of them, I drink a lot of coffee, so I thought this was really funny. It's not like Patreon, it's a one-time thing. And again, anything you guys do to help out the channel as far as buying things on Amazon list over at 3dprintedpropsgear.com, or buying me a coffee, or using the coupon code to get your printer over at GearBest, all that does is sort of give the channel a little bit of money and help me buy filament, which I am going to need a lot of for this suit. Alright guys, I hope you liked the video. I'm really excited to get started on this. We've got a few more projects before we get going on printing this, but soon enough we'll be working on this full Justice League tactical suit.